in the chat here to where we can get them up. Let's see here. Peter, we're looking for Peter. Yep, there's Peter. I got him. And Dewey. There's Peter. What's up, Peter? And Day Day. Looking for Day Day. What's up, Peter?
Hey, Peter. What's up, Peter?
Where is Day Day?
Welcome, Peter. P1000's trying to come up. Do you guys want to bring him up for 1 minute and say hi or no?
I mean, if he wants to say hello, he can. I want to. We got to get Day Day in here. Where is he?
Hey, P1000, they're doing a 2-on-2 debate, so I've got to have to drop you in a sec.
Beautiful. That's the way you do it, guys. That's all I was going to say. I was just on the other live, man, and I could just tell lowered my vibration with everybody talking and yapping at the same time. So, yeah, I'm all for that. I'll be in the box. I'll try to do what I can down there for you guys. But, yeah, 2-on-2 is a beautiful thing. Keep it up.
We'll see.
Gotta happen.
Cool, man. Thanks.
I had a problem with my audio for a second, so if anybody said anything to me before just now, I might not have heard it.
If everyone could take a few minutes before the debate gets started, share out the live with as many people as you can.
Yeah.
Let's get it out there and get some
Share the live. Share the live, please. And I'm looking for Day Day. Huh. That's interesting. Where the heck is he? Limit was going to be on your live. Well, hopefully he gets here soon. He said Earth ain't flat. So I guess
I think the time we said at first was 9:30. We'd get in and start setting up at 9:15, but start at 9:30. Maybe it's on a different time zone too or something.
No, he knows. I talked to him. I said 9:20 so we could come in and introduce everybody and just chit chat for a few. But I'm looking for him here to see if he's in here yet.
Up somehow.
Maybe. Well, we've got a backup for him. End of Days said he would do it. He would help out if Day Day's not going to make it. So hopefully that works. But so Peter, quick story. Where are you from?
I'm from Ohio.
Ohio. What's circular on the ends and high in the middle?
Circular on the ends and high in the middle.
Yep.
I don't know.
Ohio.
Oh, okay. Cool.
My dad's in Columbus.
A little riddle. Yeah, I got family in Ohio, so they're big Buckeye fans, man. It's all I hear about is Ohio State Buckeyes all the damn time.
I never spent much time looking at sports or anything.
Good evening, gentlemen.
So, and I'm looking for Day Day. If he's not here in 4 or 5 minutes, you're going to be filling in. You cool with that?
Well, I'm not actually prepared tonight.
That's okay. Hopefully he shows up.
Okay, no problem. Can you add me?
Can you follow me? I think I gotta add you as a mod. I think you have to be following me for me to do that.
Yeah, I tried to follow you, but for some reason it just keeps kicking it out. You know, I hit the follow button and then it just, I go back to it and it says follow again. So
I sent you a follow, so it might change that now. Just if you could try one more time, I'll try and add you as a mod. So
yeah, it says follow back. So I just hit it.
Okay. Yeah, you don't show up on my list of people I can add as a moderator. That's freaking weird.
It is. I just went back to it, and it says follow back again.
Isn't that weird how TikTok just loves us, dude? It's just so weird.
You're not private, right? No.
No.
Okay.
Yeah, if everyone could take a minute before we get started, share the live. And if end of days, if you're not ready, we'll probably put the invite out. If there's a qualified Glober that wants to jump up and help. Peter, if you have someone that you want to invite or like throw out there, the name out there, just let us know, Bo.
I mean, I don't know if any of the people I respect the most would want to roll in the dirt with me tonight.
Is this your day? Is it Diddy?
Daddy.
Eddie, yeah. There he is. What's up, buddy?
Hey, how's it going?
Good. Appreciate you coming on. So now that we got everybody here, I just wanted to thank the participants. And I know this isn't not exactly how I thought it was going to go. I was having some major issues with TikTok, getting my live to go with multi-guest. I've having multiple tickets with TikTok, and I just can't get it to. It's so frustrating when technology doesn't work like you want it to. So hopefully next Thursday night we'll be back and we'll be on my channel doing this again with 2 more flurfs and 2 more glurfs to learn about Earth and where we live. So since I got everybody here, I want to go over some rules. Moderating is going to be myself and End of Days. End of Days, I appreciate you helping out with this. Peter, Deddy, Mike, and Digging. I really appreciate you guys to be here tonight and taking your time out of your, away from your families to come talk about the shape of the Earth. So again, everybody in the chat, please like and share the live. This is to let people understand. So as we get into stuff, Peter shared with us, where do you live? He's from Ohio. Digging, 2 quick questions for you. Where are you from? And how did you figure out like the Earth is you think maybe flat?
Quickly, I'm from Ontario, Canada. Well, I live in Ontario, Canada, and I figured out the Earth was flat about 4 years ago by starting to trust my senses, taking observations, and pretty much questioning everything. Was the moon landing was an eye opener about the lies, and then I went down the ladder of deception and came to the flat Earth.
Okay, Mike, how about yourself, buddy? Where are you from? How'd you figure it out? You're muted.
Well, I'm up in Canada, British Columbia, Canada. How did I figure it out? Well, I guess I had a humbling experience after being a jerkwad to someone, and then they passed, and it made me kind of like question why I was such a jerkwad. Sorry, trying to get away from my kids, and then I got fucking chickens here. Too funny. If it's not one thing, it's the other, right? But yeah, no. So then I looked into it, and it was Polaris and the celestial bodies mixed with the fact that there's no visible curvature over water. So that was it.
Gotcha.
Hey,
And
hey, Enoch,
Yes, sir.
if you're not able to add me as a mod, do you mind if I interject if it gets out of hand?
Of course.
Yeah, absolutely.
That would be your role as a
Absolutely.
mod for sure. Yeah, no problem.
Yeah, because I just want this to be a smooth sailing ship. I
I have a
too,
feeling
buddy.
it'll go that way, and I'm going to keep trying periodically every 10 minutes or so to add you, but I'm on it right now, add moderators, and then I type the 0 because you have a 0, and nothing's coming up for you.
I just checked it again, and it said follow back, and I just selected it again. So try it right now and see what happens, because it says notifications and.
Okay, I'm clicking on moderators, add, end. Yeah, I'll try again in 10 minutes, but please interject. You're a moderator.
So I'm going to
As a mod.
hold on. I'm going to Day. Where are you from, my friend?
Hey, I'm from Tel Aviv, Israel.
Tel Aviv. Awesome. All right. And why do you believe the Earth is a globe?
Well, first of all, I never had a reason to doubt the scientific community because, everything they do is, those are things that rely on our understanding of the universe and on logic.
Yep.
And second of all, like I myself have seen, many evidences that show that we live on a globe, like things that you can't deny, that simply won't work on a flat Earth. So
Gotcha. Okay. And Peter, you're from Ohio. What brought you into this topic? I know you've only been on TikTok for a little while. Why? Why is it important to you?
Well, I've actually had a giant YouTube video debunking flat Earth on my YouTube for about 5 years now, but nobody paid attention. It wasn't until I started putting clips of that on TikTok that my TikTok profile got some traction. So I've technically been in the subject for at least 5 years, more like 7 if you count when I very first heard of it and started researching. I mean, the fact is, there is no viable flat Earth model that works with time zones and seasons. Robothemism, which is what I call the model that has the sun traveling in a circle above the Earth, that is incoherent and anti-scientific. So basically, as long as I've known about time zones and as long as I've, been able to watch the sunset, that's how long I've known the Earth was a globe.
Gotcha. All right. So just so you guys are aware, and you guys are keeping me in check, nobody knows what these subjects are going to be talked about, correct?
Nobody knows.
Nobody knows. I have not shared anything with anybody. And just so that both teams are aware, Digging gave me 3 questions to ask the Globers, and Peter gave me 3 questions to ask the Flat Earthers. I also got several questions from Roundhound to ask the Flat Earthers, and several questions from Vika Drazik to ask the Globe Earthers. So,
may I ask you a question?
Yeah.
Very cool.
Who's actually going to be debating for the flat Earth side?
So it's going to be Mike and Digging are going to be debating. I'm just here moderating and asking questions, and then giving each team a chance to answer. And you can see here, I got my little stop clock here in the comfy of my living room. I hope you guys are all comfortable as well. I got my topics here lined up, ready to go. So I'm gonna ask a question to everybody. We're gonna start with Digging. Digging, are you open-minded, and are you willing to accept that you may be wrong?
Totally.
Okay. Mike, same for you. Are you open-minded? Are you willing to accept that you might be wrong?
Yes, absolutely.
All right. Very good. Peter, same for you. Are you open-minded? Are you willing to accept you might be wrong?
I'm not going to be dishonest. Confirmation over and over and over does tend to bias one toward that conclusion. I've never heard any convincing argument from any flat earther, so I'm not really expecting to be wrong tonight.
Gotcha. Okay. And Day, same for you. Are you open-minded?
Absolutely.
Okay. Very good.
So I'd love to be proven wrong.
All right. Very good. So how this is going to work, we're all here to learn, to seek truth, to find wisdom, and learn knowledge, right? So how this is going to work is I'm going to ask a question. There's going to be topics in no particular order that we're going to talk about. Each side or each person that I ask is going to get 3 minutes to answer your question. If you want the big box and you want to go on screen to show a video or an example or a whiteboard or to put something on, just tell me you need the big screen, and I'll give you your 3 minutes time. If you need an additional 20 or 30 seconds, just let me know. I plan on letting you know when you've got about 30 seconds left of that 3 minutes. And then I'll give the other team 3 minutes to rebut, and then I'll come back to you for an additional 1 minute or so follow-up. Sound good?
Yep.
So nobody is going to be talking over one another. I ask that you just go ahead and mute yourself when you're not talking. And so I don't have to do that. We're all here respectful of one another, and just keep things, no ad homs, no attacks, no foul language, as we don't want to get the live shut down. This is very, very important to us. So we want to get the word out as much as we can. All right. So moving into the topics. The first topic is going to be why things fall. Okay. This question is going to be for Peter. Okay. So, Peter, if you could, what is gravity? Is it a theory or a law? Okay. And if you could, please explain why gravity sometimes makes things stick, allows objects to orbit, spin, become tidally locked, allow objects to slingshot, and or what is the bending of space and time in regards to gravity? You got 3 minutes.
All right, the first thing I want to say about that is that it's a red herring on the topic of the curvature of the Earth or the shape of the Earth. Scientists figured out the Earth was a globe for thousands of years before gravity or the fact that things fall was studied in any scientific way. If you look at history, most of the people in the medieval period, at least the educated people, knew the Earth was a globe. They believed it was a geocentric globe, but a globe nonetheless. And they had not yet studied gravity or why things fall. So it's a complete red herring on the topic. However, we can entertain it briefly. I will be fully transparent. I don't fully understand Einsteinian relativity. I am learning a little bit here and there about it, so I can answer a few questions about it. But again, it's a red herring on this topic. I know a lot more about Newtonian gravity, which still applies at all pedestrian scales and for most celestial mechanics. So your question about space-time curvature does stray a little bit into territory I cannot answer. But it's not relevant to the
How
topic
by the
of
way,
today's
you
debate.
made this spot in for Einsteinian gravity. So
Excellent. So direct questions about that to Deddy. There is both a theory and a law of gravitation. The law is how things work, how we observe the mechanics to work. And it is force equals the mass of one object times the mass of the other object divided by the radius squared or the distance squared between them. If I'm correct, I think I remember that correctly. The theory of gravitation is the conceptualization of why that works. And that's why it's called a theory. But there is a law of gravitation, and that's that Newtonian equation. I think it's the second law of motion, and it is obeyed all the time, except in relativistic situations. Basically, why things orbit is it's just like if you throw a ball sideways, it's going to follow a parabolic arc when it hits the ground, or before it hits the ground. That's because it doesn't have enough sideways velocity to actually go around the planet, but it's the same mechanics at play. That's why when NASA launches a rocket, you see the rocket goes.
You're almost 3 minutes up, but I'll give you 30 more seconds. Go ahead.
Okay. The reason when rockets launch, you see them go sideways instead of up, that's because in order to achieve low Earth orbit, the object has to achieve tremendously high lateral velocity, sideways or longitudinal velocity, in order to actually basically miss the Earth as it's falling toward the Earth. That's what orbit is. I don't think I had time to address every detail of your question, but
All right, we'll get back to you and after this, but thank you for that.
Hey,
All
Glo,
right.
is there any way you can please show the timer? So
Yeah. Hold on. I just stopped it at 3 minutes. Yeah, that's a good idea. Thank you for that. I'll put the timer on here so you guys can see it.
yeah, this way each individual has an idea of how much time they have left and how much time is running.
Of course. All right. So here you go. He had 3 minutes and 30. All right. Digging. Same for you. Why do things fall if the Earth is flat? Oops.
If the Earth is flat, why do things fall? Well, to my belief and my understanding of what I see and what I've read, it's basically due to buoyancy, density, and electrostatic and electromagnetic force around us. The buoyancy is so gas pressures and all that are due to buoyancy, right? So in the atmos around us, we have what we call the atmosphere gas pressure gradient, right? So it gets lower as you go into the atmos. And also at the same time, we have a electrostatic potential gradient, which increases as you go up in altitude in the atmos. So there's a direct correlation, in my beliefs, to both things, right? Because with the electrostatic potential increasing, it increases the space in between the molecule or the atoms that are seeking equilibrium inside the electrostatic or electromagnetic realm that we are there. So I think that's direct correlation of why things drop down, because the pressure gradient is heavier at the bottom, and everything with the two pressure gradients and electrostatic potential gradient affecting, making a downward force. I do not need to explain on the orbits of things in the sky because I don't believe in gravity. What was the rest of the question?
Just like why things would fall on a flat Earth? Why? What is if it's not gravity? What is it?
Density, buoyancy, electrostatics, and electromagnetic. Oh, those are the four forces or four variables that need to be calculated, basically, to make things fall or go up. Because things go up also, like heliums and all gases, they tend to go up to seek equilibrium with their density or their neutral net zero charge, because everything around us is at net zero charge and finds equilibrium to the ground, which the ground is Earth. That's why we call it ground. So yeah, that's my belief.
Okay, thank you.
Just talking. Yeah.
Day, do you want to follow up for that? 30 seconds.
Yeah, I do. So you're saying you're speaking about gradients of pressure in the atmosphere, and nobody argues with that. But the question is, why is there this gradient of pressure? Why does it also sorts thing according to density? Why do, for example, less dense things go up? Why do more dense things go down? For example, when you look at this glass with alcohol, oil, and water, why is it sorted that way? Why aren't they, just floating around? There's a reason for this direction, up and down. There's a reason that up is less dense and down is more dense. It's gravity. Without gravity, without something that will pull them to this direction, they won't be sorted. Okay.
Okay, Mike, you got 30 seconds.
I've got 30 seconds for my point or a rebuttal to.
A rebuttal to Day, or add on to what Digging was saying.
All right. Well, I mean, everything in this realm, in this world, is sitting within a medium. And within that medium, all objects are going to try to find its equilibrium, just like what Digging was saying. What you're talking about, Deddy, is what we witness objects finding its equilibrium. That can be within sand or water or air. Some of us might call it ether. We can see this with like helium, hydrogen, oxygen, even propane that settles, right? So there's your layering. There you go.
Gotcha. Hold on. I'm going to ask another question about gravity. So how do we know gravity exists in space if we can't go there and we can't test it ourselves?
Is this question for me or
for Day? Sorry.
So first of all, again, you didn't really explain why. Like you're saying, objects search for equilibrium. So what is this equilibrium? What decides this equilibrium, and why they search this equilibrium? You don't explain any of those. You just say yeah, objects search their natural places, equilibrium, whatever kind of thing that you're trying to say, but you don't explain why. Okay, this is what science tries to do. It tries to explain why do things want to go to the ground, and the reason they want to go down is gravity. Okay, so do you want to do you want me to
The space question. Why do right? How do we
I think it
know?
was 30 seconds there, didn't he? On the
Yeah.
wrong question.
Yeah, that I'll give him another 30 seconds. Day, stay on topic. How do we know space exists or gravity exists in space outside of Earth? How do we know?
So just as we know that magnetism, for example, exists, and magnetism, stretch to infinity. So just as any other force doesn't really have a reason to stop after a specific distance. Everything extends to infinity. So if gravity exists here, it exists in space. It exists everywhere. Your tiny body's gravitational pull even pulls stars thousands of light years away. It's just very small amount.
Gotcha. So is that because in my interpretation of it, and Peter, you can chime in here, is dark matter makes up like 95% of the heliocentric model. That's what they call gravity, and they really don't even know what it is.
Your use of the term heliocentric here is not correct, but you are correct that dark matter is a theorized answer for a certain discrepancy in cosmology. That doesn't negate the fact that, we have been to space. The International Space Station is in orbit because of gravity. Every probe we've ever sent to any other planet has obeyed the laws of gravity, and that's how we navigate. So I don't even really understand why you're asking the question.
Okay. Digging, how do we know gravity exists in space if it does?
Okay,
Or
so
light?
I can rebuttal to that. Like, can I get the big screen and play a little clip of Neil deGrasse Tyson explaining quantum gravity issues with another
Yeah,
physicist?
you got 1 minute.
Okay. Just let me turn on my cam. Okay. You can see. Why would it play?
This is Jan 11 talking about gravity. Take a listen.
Quantum gravity requires that space-time be quantized, but there might not be a theory of quantum gravity. We might look deeper and deeper, and instead of finding quantum bits of space-time, we will only find pure quantum mechanics with no gravity in it whatsoever, and that gravity emerges only out of the collective of tons and tons of these quantum interactions.
That's crazy.
So that just like water, it's like, yeah, it's crazy.
So the quantum interactions manifests as what we call gravity.
Right.
That's
the way
right.
The ensemble of H2O
Manifest as water.
Exactly.
That is, right. And the
Exactly.
same way you would pull out a single molecule, you're not necessarily looking at water at that point.
Right.
The
You
same
can't
thing
pull out.
with the. Oh my!
You're telling me
You
that
can't pull out
gravity,
a quantum and say, is this gravity?
Right.
Is this space-time
Is this
anymore?
space-time anymore?
Exactly.
Janet, you're saying gravity might not exist as a fundamental thing in the
I'm
universe?
saying gravity might not exist as a fundamental thing in the universe.
Wow.
All right.
110
So
pounds
Peter,
anvil.
Peter or Day, do you guys want to respond to that for a minute?
May I interject?
Yeah.
I don't believe Neil deGrasse Tyson is debating.
I'm just
They're talking.
they're talking. They're talking about the subject of gravity.
Okay. All right.
So Peter or Day, do you guys want to respond to that from digging?
So I do have a thought. Maybe Deddy has one too, but the topic of quantum gravity is not the same as the topic of gravity. I don't know if you guys are confused on that. Quantum gravity is a very specific problem in current physics. And as a matter of fact, Dr. Blitz, who some of you may know, he's a PhD physicist here on TikTok. He just recently submitted a research paper on the topic of quantum gravity. It's a frontier of active research. So it's not the same as just the topic of gravity in general. You guys are just misunderstanding.
All right. If you could, Peter, maybe in your spare time, shoot me that article. I'd like to read it in my DM.
Same.
Awesome.
Dr. Blitz?
Yeah, or yeah, if you have access to it, that'd be great.
I'll see if I can find. I don't know if it's public yet.
Okay,
I'll see if I can find it.
that's cool. All right, we're gonna move on to the next topic, guys. First question is gonna go to the flat earthers. It's gonna be this next category. By the way, we just spent about 20 minutes or so in the gravity sector, 15 to 20 minutes. So we're gonna move on to another topic. Next topic is gonna be what about curvature? Okay, Mike, this question is for you. Do you know how much curvature is the globe Earth? And you know how that is measured?
Yeah, you bet. So the curvature rate of our ball is supposed to be 8 inches per mile squared. That's measured from a tangent point, along a distance. So the issue with the curve and what the model represents is that it's not measurable. With the surface of this planet being covered with 70, I've heard 71, I've heard 75, I'll just say 70% water, and water always finding its rest, or sorry, finding itself flat and level at rest. There's no measurable curve, and this is one of the easiest ways that I've found. I can go out and make an observation that blows this whole model out of the water. Of course, there's other things that come into the conversation when it comes to why we can observe things as far as the globies like to go. But that's a whole other conversation. If I don't think you want to go down that level of it right now, so I'm just gonna hold up and let you continue. Continue. Does that answer? Like, is that what you're looking for?
Yeah, that's what I'm looking
Cool.
for. Day, can you agree to the 8 inches per mile squared for the globe model?
Well, it's an estimation. It's not the perfect formula because you're on a sphere. So essentially, if you go far enough, you're gonna come from the other side. That's what I'm saying. But I mean, it's kind of a good estimation. It's up until 100, 200 miles. I guess it's an okay formula to calculate the curvature.
Okay, so can
I
you?
take into consideration the refraction of the atmosphere, though. But still, it's a good estimation.
Okay, so can you give us an example where you have done a curvature test to prove that it actually is a ball at 8 inches per mile square?
Yeah, sure. But before that, I just want to show you something. Okay. This is like just half a sphere, right?
Mm-hmm.
I want to show you what 1 degree of curvature looks like. Okay. So those bars represent 1 degree, and 1 degree on Earth is about 70 miles. This is the curvature of 1 degree. You see anything curving here? Like with your eyes, do you see anything curved?
I would
This
love
is
to
1
respond to
degree,
this.
70 miles. Okay? It's a very, very small curvature.
Okay, can I just add?
Okay? So wait,
Yeah, hold
wait,
on,
wait.
guys. Hold on. Let him have his time here.
Can you finish? Okay. So when guys ask which height I need to be to see the curvature, they're speaking about curvature from side to side, not like this, okay? And when we say that we see curvature, we don't mean we see the curvature itself, but we see the effect of curvature. For example, if you look at this image that I shot just a few days ago, you see the effect of curvature by this boat here that is supposed to be visible like those, but it's below the horizon, and you see only the pole of the boat. I actually
Daddy, how much drop is over
Hold on, Mike.
one degree?
Hold on, Mike. Let him
I'll
finish.
just finish. I actually shot this boat too, and you can see that you suddenly see it because I kind of took the camera up and down and show that when you go lower, then you even see less of the boat because of curvature, as you see right here.
So Day, what's your elevation?
Down, and this is like this is my height. Like this is about 1.8 meters.
Okay, and do you know how far away the boat is?
I can estimate, but I don't know the exact number, so I don't want to, just throw in a number. But the fact that you see boats here, and this one, which is further away, because you can see that it's smaller, so it's further away, but you can also see that it's cropped from the bottom. The boat's somewhere around here. So
Okay, you got about 20 seconds.
the curvature. So the effect of curvature is something that is very easy to see.
Okay.
That's it. I finished. You can.
All right. Mike, do you wanna answer that? Do you want to respond to that?
Yeah, you bet. I don't. Oh well, I do have my computer here. I might be able to whip off some quick math here while I'm responding as well. But what I wanted him to go into this a little bit more was how much rate drop or how much curvature drop there was over that 1 degree, because
You want the big box, Mike?
Yeah, sure. I would love the big box. Just trying to whip up my calculator on a new computer, and I'm a hammer swinger, guys. Just give me a quick second here. All right. Oh, that's not calculator. That's calendar. Okay. I'm sorry, guys. All right. There we go. All right. So here's the one thing that I wanted to bring up was here's your picture. I just took a screenshot while you were explaining. Would you agree with me that this looks like part of the bottom of the hull is just disappeared?
No,
it's completely gone.
Not a part of the bottom, like the top of the boat.
The effects that we see over this vast distance is distorting this image. It's clear, right? Also, from the viewpoint of wherever this picture was taken to this boat, do you know what the distance is?
I would say about 10 miles, maybe less, like maybe 8 miles.
So the difference, so the problem with that, so hold on, the problem with this is, Daddy, is you don't have the data on this. You can't bring us the measurements of this. So it's a very hard thing for us to debate. And I would beg to ask, this is a huge ship, dude. And the amount of time that I spend on water, 10 miles, bro, this is not 10 miles. This is way further than 10 miles. So I'm just going to punch in, hold on, I'm just going to punch in your figure really quick.
Tell because you don't know the zoom that I use.
Hey, hold on.
Well, I understand that, but if we want to talk about and have a debate, then we're going to have to bring tangible evidence, and we can't just say, well, I think it's this. We need to actually have a figure and a way to show that, right? So the problem that we've got here is you've got a curvature rate drop of... Hold on, you've got a curvature rate drop over one degree is 3,360.66 feet, dude. That's a huge rate drop. So I don't know where you see that over the 1 degree because it's not measurable. When I look over a 5 or 10 mile observation, I can see the objects from that distance over 5. Hold on, just to finish my point real quick here, Daddy, and then I'll mute. You guys can continue. But over a 5 mile observation, there's supposed to be a 16.6 foot drop. That's 200 inches, bro. And what I can see over a 5 mile observation with around a 30 inch, I'll tell you around, I give it a 5 foot observation if you want to go that far. But I was sitting on my butt on the shore with my feet in the water, and I was using my P900, and I could see the leg of these outboard motors in the water, right, like the boats were beached up. This was 5.8 miles away. So the curvature rate drop's not there. There was nothing that did bring us back into viewpoint. So unfortunately for me, it didn't prove me anything except for that this earth is flat, bro. Thanks.
All right.
I'm gonna mute.
Thanks, Mike. Let me stop that. All right, Day or Peter, do you guys want to respond? You guys get a couple minutes.
Yeah, I'll give Peter the opportunity to respond, but I'll just say that this is 70 miles. We were speaking about much less, and here you can see like almost zero. Okay, so
rebut to that, by the way, to that exact image, right? Because in order to see 1 degree, 70 miles like that, how high do you need to be? And how big do you need to be to see it like that? Because right now, what you're showing us right now is more than 210 miles. We don't see 210 miles. So you would need to get really, really, really closer to where you can see 3 miles and see if there's curve.
do you understand why I even showed you?
Yeah, just divide that 70 by 10. You get that's 7 miles
that
right
doesn't describe what we see in reality because it's a line on a computer. It doesn't describe what we see in reality. You make us look so much. You'd have to be like
half a circle. You deny that this is half a circle?
I do not.
No,
deny
we agree that
right. So what I'm asking you, The only reason I show this picture is to show to you that even in 70 miles, the curvature is so mild that you won't be able to see the curvature.
Yeah, but dude, what's the number?
It doesn't matter. Like, the curvature is still curvature. It doesn't matter
does
which
matter.
side. No, it doesn't.
To your scale, bro, you can't see it. You wouldn't see it that way because you don't see 70 miles in one in front of you or on an arc.
You even see less than 70 miles. That's right. That's why I'm saying this looks almost completely straight.
Okay. So my follow-up question to Day Day or Peter is, if you guys are saying we can see the effects of curvature from I guess front to back or back to front, why can't we see curvature from left to right? At what altitude would you say we have to be at to see curvature from left to right?
Are you kidding me?
How long do I have to answer that?
I'll give you a couple minutes.
Okay. Can I take this, Daddy?
Yeah, sure. Go ahead.
Okay, so while you're at ground level, next to sea level, the horizon between sky and ground, or sky and sea, or whatever, is an orthodrome on your celestial sphere. That means it's a great circle going around your head, 360 degrees. You will not see curvature in the sense that you're referring to, left to right, at that altitude. That's the wrong way, that's the wrong methodology to measure this entirely. What you want to see, what you want to measure, is drop away from that orthodrome. And I have a, can I have the big box?
Yep, I got you.
I'm trying to figure out how to switch to my other camera. Darn it.
I'm going to give you another minute or two, a minute and a half or so.
Thank you.
Oh, here it is. Here it is. Okay. Oh, shoot. There. Why is it not working? Okay. I don't know why it still has the menu up, but whatever. So this is a balloon launch that my friend did. It went up to 120,000 feet.
I'm not
he
seeing
sent me these.
We're not seeing it, Peter.
You gotta flip the camera, Peter.
Yeah, no, it's closed. Like, close the camera and open it again. Like,
Oh, okay. I see
There you
why the
go.
menu is still up. That's why. Thank you. Thanks for bearing with me. So you see it now?
Yep.
Okay, so this is a panorama that my friend took from 120,000 feet. You can see that he's processed it into 5 faces of a cube here that he sent me. And I can put them back together and put the camera in the center, and it recreates the panorama. This is taken from 120,000 feet, and if you look at the cube, there is drop away. And there is exactly 6 degrees of drop away. That's how much the horizon was deviating from that eye level orthodrome that it would be at sea level. That is how you measure curvature left to right. And that does match a radius of 4,000 miles.
So what type of lens was used, Peter?
Panoramic.
A panoramic lens. Okay, so a wide angle lens.
It was a panoramic camera, so I think it was an array of lenses that was stitched together inside the camera.
Okay. Digging or Mike, do you guys want a couple minutes to respond to that?
Yeah, I mean, I do enjoy the pictures. Can you bring those back up again? Is there, I'm assuming he's got some sort of a gimbal or, fucking, why am I gapping on this? A gyroscope in there?
No, it was oriented upright after the fact in post-production. That's why he took a panorama. You can do that with a panorama.
Okay, how are we sure that these cameras, like, are these are multiple lenses that are taking these shots?
It is, but it's stitched together, like on Google Street View. You know how
Right.
Google Street View does that, but it's
I understand that. So they're taking a 360 degree panoramic shot, right? That's what you're saying.
Yes.
And you're saying that you're seeing drop like along 5 sides of a
No,
4
four
sides of a
sides.
cube.
5 because it includes the bottom, but you wouldn't see the horizon on the bottom.
Right. So every one of these has this 6. Is it every picture has this drop?
The horizon
within the
runs
4?
through. The horizon runs through 4 sides of the cube, and
Yeah.
on all 4 of those sides, it falls short of the middle of that face of the cube by a measure of 6 degrees.
Oh, okay. So the cube is neither here nor there. This is 4 pictures that you're showing us that are put together. Okay. Gotcha.
Right. The cube is just
And this is
representing
with
how
this is with a wide angle lens, right?
Wide angle isn't. I don't think that's the correct term here. It's a panorama.
All right. I'm not a huge.
I got a question.
I'm not a huge camera guy, but as far as I understand, they're not far off. I use panoramic with my phone, and I do have to keep it level, or it does distort my imagery. So, but I can't really speak too much to that because, yeah, I understand that. But we could just say, well, that's because that's the way this does it, and that's not how the way this does it. But if they're both a wide angle lens, I don't understand what the difference is. But
Orientation
again,
of the camera doesn't matter.
I'm not a professional.
Orientation of the camera doesn't matter if you can show more sky than Earth, because at ground level, if it's an orthodrome around your eye level, it should be equal parts sky and Earth. If there's drop away, that means more sky than Earth. This shows more sky than Earth. It doesn't matter if the camera is oriented upright or not.
But the reason why I ask is because, like, how fast we're gonna need to know things like shutter speed and stuff, because this balloon is gonna be moving and stuff, right? That's why I asked about the gyro.
Well, it was like a 3-hour video. I have a link to the video if you need it.
Yeah, well, it'd be cool video to watch anyways.
Digging. Do you have anything you want to add?
Well, the thing is with that is, what's the field of view and what's the angle field of view of each shot?
In this case, each face of the cube would be a field of view of 90 degrees, adding up to 360.
Okay, so 90 degrees would tend to go into the wide angle lens. So it would add some compression on the edge, like a wide angle lens.
It's a panorama. It's a panorama.
Yeah, but
I don't know if you
panorama or whatever, you get a field of view of 90 degrees. It needs to compress at one point.
A panorama has a field of view of 360 degrees.
Okay. So when you use a regular lens, what's the regular field of view angle that you see? I think it's up to like 70 degrees or something like that.
That's not the lens.
Yeah, that's highly variable.
Huh? Well, I'm asking.
I'm going to interject. Can we please let each other finish before we start talking?
What's Digging? Are you asking questions about this, or do you have anything else that you want to add about the curvature?
Oh, I don't know enough about photography and lens to argue on that point, because I don't know where the definition of wide angle lens and what it does to. I know he's saying panoramic, but to me it sounds like a wide angle lens, which compresses a little bit of the not compresses, but to get
it's
more
applicable here.
To get a wider field of view, to get more of the land, you widen the lens. And then there's also refraction to get in there. There's refraction level because there's still atmos that the light is going through and bending and stuff like that. And refraction can go either up or down depending on a lot of variables. So, yeah.
Mike,
I'm sorry for speaking over you.
Mike, you got 30 seconds.
Hey, yeah, no, I mean, because I'm with Digging on this. I'm not a huge camera guy. I just bought my camera myself, but I did just Google it for what it's worth. Panoramic photography distortion, and there's a lot of articles talking about fixing. I can show you a real quick example of distortion caused from a panoramic lens. Let's see here, trying to bring it up. Turn the camera around. There we go. So here's one of the shots, and I can go back, and there's a whole bunch of different viewpoints, because this is one of the benefits of using panoramic lensing is you can do some really cool photography, but panoramic lenses do cause
those are not applicable to this. Because
well, I understand
a panoramic image
Okay,
is
sorry, I'm just gonna interrupt you because
can't
end of
represent
days
it
just hold
without
on,
projecting
Peter.
it.
Peter, end
Or
of days
projecting
just talked
it. And
about
those are
this
just
talking over each
artistic
other.
projections. They're not
All right, go
applicable
ahead.
to my argument
Yeah,
at all.
go ahead. Yeah, you let me know when you're done so I can finish replying.
What is applicable is refraction. I haven't heard anyone bring it up yet. So do you account
Is
for
Mike
refraction
muted?
with this drop?
No, I'm not muted. I'm just waiting for this structure to return. Peter, you need to discipline yourself a little bit, please, bro.
I guess the question I'm asking is, Peter, I'll ask the next question to the Globers, either Deddy or Peter. Have you guys done any experiments on your own to prove the 8 inches per mile squared?
Yeah.
Okay, Deddy, can you explain what you did and how that works?
Look, the fact that the curvature is so small at small distances means that sometimes refraction can play a big role in it.
Okay,
What do I
Deddy,
mean by that? For example, wait a second. Let me just finish.
did you measure the curvature of 8 inches per mile? Have you done any scientific experiments using the scientific method
Well,
to
I'm trying to
measure the
answer.
curvature
Okay,
at
I'm
8
trying to
inches per
answer.
mile squared? Okay.
I'm trying to answer. Okay, so to measure again the 8 inches per mile is like it's useless, and I'm trying to explain to you why. You see that the sun looks like it's a bit squashed here, right? So the further away, the effects of refraction like this and this are they affect a lot more size. For example, if the sun is a million miles, then those this small difference in size here is like tens of thousands of miles. So the fact that you would say like at 60 feet an object should be hidden, I don't know, 300 feet, that doesn't mean anything because small refraction can account for that 300 feet that is visible or isn't visible. But what you can't see, okay, is something, for example, 1,000 miles away on a sphere, because it's like completely blocked by the horizon. And that's why when something sets behind the horizon, like you can see the sun that I shot here from my porch, this is something that can't be explained anyway, anyhow else than the horizon blocking the view. This is not angular resolution because you can see you have resolution. You can see the shape of the sphere, so you have resolution. You can resolve the object. This is not perspective because it's not getting smaller. It's just moving down and being cropped from the bottom. No amount of zoom, it doesn't matter which telescope you use, you can't bring this thing back up.
All right, we're gonna go back into since you just brought up the sun. My next question is for digging, or Mike, and I'll restart my. I'll stop this thing and reset this so we're at, just so you guys can see we're at 9:19. So you got 3 minutes on this one, digging. Can you explain why the sun? Hold on, I'm gonna ask this question straight as it was asked. How does the sun?
Is there any way for you to set the timer and run it backwards?
Dude, this thing is such a pain in the neck. It's like it wants to go to like a commercial. It has ads on this stinking timer. It sucks. But anyway, I'll ask the question and then I'll hopefully by the time I'll give you 3 minutes to answer. Yeah, it's crazy.
All right, so this is going to be 3 minutes.
How does the sun set while staying physically above the flat Earth? Can you explain that, digging? How does the sun set while staying physically above the flat Earth?
Well, in our explanation is because of how perspective works, right? So how your eyes work. So it's basically the same concept of if you're moving on, like, let's say a 2 mile long flat road, and there's a bunch of light poles. As you move away from the furthest one from you, it'll look to get smaller and smaller and closer to the ground. The same thing happens with the sun, but when you're starting to talk about the sun, you need to consider a lot of variables, because the distance of the sun, the distance to you, refraction, and the perspective. So if you take all those into consideration, and you get the perfect, like a good field of view where you can see really, really far with a solar filter, not zooming in. You can time lapse and you can see a difference in the size and shape of the sun. It shrinks a little. It doesn't need to shrink much, like they say. Oh, it would. No, it doesn't need to shrink much, because at one point you can't resolve it, and there's going to be too much medium in between you and the sun, blocking its light, because there's a lot of medium around you, oxygen molecule, gases and stuff like that, pollution, whatever, terrain, trees, water, waves. So you won't be able to resolve it at that point. But if you can see it further enough, so if you're higher in altitudes and you can see it go further and further from you, it will change in apparent size. And that's how it works on a flat Earth, basically. I'm trying to look for a video, but if Mike want to take the rest of my time for that to set his opinion on that, he's good to go. But basically, there's a lot of variables in context.
I'm going to ask a follow-up question for Mike. How do ships disappear bottom up first on the horizon? Why is that?
Okay, can I cover both of those, and then can you kindly give me just a hair more time?
Yep.
Okay. So just to carry on to what Digging was saying, is that this is how we see, right? This is how things come to a vanishing point as we're standing and looking down a street. I've got real life pictures and examples of this, but in lieu of time, I'm not going to bring them up. We know that our eyes reach a point of convergence where we can't see past that. That's our vanishing point, right? Now, everything above this is going to be a little bit lighter density than everything below this, because that's how density works, right? So when we've got an object that's going way far away from you, there's the effects of what I like to refer to as atmospheric distortion are going to stack up. Like if you've got, say this is 100 feet, and you've got 100 feet worth of atmospheric distortion right here in this space, and then you've got another 100 feet and 100 feet, this is going to compound over distance. So the further something gets out, depending on your atmospheric conditions, the more that this is going to be distorted on the bottom than it is on the top, just like this picture. Now, the other side of this equation, why it looks so cut off on the bottom, is the same reason why I can cover the Eiffel Tower with the tip of my thumb if I want, if I'm the right distance away. That doesn't make my thumb bigger than the Eiffel Tower, right? So same thing, as that boat's going away, first of all, the hull is always in the water. So when people are saying, we can only see a little bit of the bottom, well, there's always only a little bit of the bottom you can always see anyways. But as you get a little bit of waves, even like a 6-inch wave, and if you're at the right angle, that wave is going to cover a great deal of that boat. It's going to appear as though that boat's disappearing from the bottom up. And if any of you guys have spent any amount of time on the ocean, as you get closer to land, either you've got crashing waves or things start settling down. But if there's any amount of current around, those waves get brutal. They're high, it's like the high seas before you get out into open seas and things calm down a bit. So that would cause a lot of that blocking of that larger object if there was more churning of the ocean between where you're at, the beach, and where that boat's at, right? Whether that's the sun or whether that's the boat itself. Now, if I can, real quick, I'm just gonna bring up one more picture, because I'm cooking and it's getting fucking hot in here. And 30 seconds. Give me 30 seconds on that 30 seconds, just because I gotta bring up this picture, and I got a ton of them. You know what? That's okay. I'll bring this one up anyways, because what I was gonna bring up is a picture that I think both of you or all of you have seen before, which is that garage door that I stand beside, where the top lines come down and the bottom lines come up, just like that perspective shot. And if that sun is traveling way above our heads, just like a plane, those lines of convergence are going to make that sun come down to that vanishing point that looks like it's coming down, just like those lines on that garage door. There's a point where they look almost vertical. That's perspective, right? And finally, this is a beautiful example of why we can't have curvature on our Earth. We don't have this example.
Yeah, you changed the subject.
We only have these, right? So,
not waste time?
no, it was all about the sun, and it was all about ships, bro. So don't be crying.
Day, can you give Day? I'll give you a minute or two, or you and Peter can respond to that. You want the big box, Peter or Day?
I just you want to go, Peter? I just wanted to ask them one question.
Well, What question you got for Mike or digging?
So you're talking about perspective. Do you know why things look smaller when they're when they're further away? Like how perspective works? What's the reason they look smaller?
Yeah, it's convergence. It's the way that our eyes focus in on an object.
No, it's not.
What is it,
What's
Day?
what's the reason for this? Why are those tracks look, why they're here than they are here? What's the reason?
Triangulation, bro.
What do you mean triangulation? Can you explain the reason behind this?
Hold on, Daddy. We're here for a debate. We're not here for you to ask me about my fucking knowledge. If you want to bring a point to the table, you should do that. I'm trying to give you answers, and you're not. So go ahead and make your point.
Yeah, you're saying that this happens because of perspective, right?
Well, I didn't bring it up just perspective. There's a couple things that make that effect. Yeah.
Yeah, perspective and other nonsense about refraction or whatever.
You're right. Yeah, well, refraction's nonsense.
That should
You're
look
right.
like this is cut in half, and is
And
hidden
might be muted.
by this
Oh,
object.
he is muted. Okay.
The ocean, right? You're not explaining that. So you're not explaining actually why perspective does this, okay? And Digging for Truth also said that things look like they're going down by perspective, and they're not going down. They just go smaller. So if the height of the object is above the horizon, then it looks like it's going down, but it's just getting smaller. Just as this thing is getting smaller and it looks like it's rising up, right? So all the distances between 2 points will look like they're closer. All the distances will go shorter as they go further away, and that's because the angle that this takes out of your field of view is smaller as it gets further away. It's just angles. It's simple geometry. Nothing.
That's exactly what I said, bro. Lines of convergence. It's perspective.
Nothing in perspective can make an object look like it's cut in half. If the sun was going away, it would look smaller and smaller. And
Digging.
You know what? I'm gonna do you a solid, bro. I'm gonna put this summer. I'm gonna put an exercise ball on the lake, and I'm gonna show you how I can cut that ball in half while it's floating.
I don't believe that Deddy asked Mike a direct question. Can someone mute Mike?
Yeah, we got it.
I don't believe that you need to do that either, Peter.
So
you can see
in fairness, Globe Denier, because you're the mod of this, I've been cut off throughout my answers from this guy and from this guy.
Yep.
And they both we got called out by this guy, but
I asked you guys, hold on.
If we interrupt you, then just say so. That's okay. We're not perfect, okay? If I interrupted you, then I'm sorry.
I tried, and he wouldn't shut up, would he?
I actually only had to respond to you like in 30 seconds each time.
Day, hold on, Day. As I'm watching this, you and Mike just explained the exact same thing. Both explain what convergence is and what a vanishing point.
I explained what convergence is, but it's not what the sun is doing here, right? Because it's not getting smaller. And you can see in this time lapse that is from, I think, about 2 p.m. to sunset. One second, let me just finish the sentence. The sun here looks exactly the same size as it does when it sets. It's exactly the same size. It doesn't change size at all, so it doesn't go further away, as you should be able to see if the sun, was shrinking due to perspective. It's the same exact size the entire time.
Okay, I'm gonna give Digging and Mike 1 minute to respond to that, and then we're gonna move on to the next topic.
I mean, I took Peter's time, so I think you should let him speak.
Yeah.
Well, you took Peter's time.
The sun does.
Peter, do you have anything? Peter, do you have anything you want to add?
To respond.
I thought
Peter,
it was my.
anything you want to add?
I had an outage in my audio, so I missed some of what was said. You guys should just move on. Thank you, though.
Okay. Yep. Digging. You wanna respond to that? Why the sun looks like it's doing that?
Okay, so Enoch has got it changes in apparent size. He's got it on there. Rib Globe made some observation. We can observe that the sun a change in apparent size. So that's a fact. And then I want Deddy for the big box, and I want him to show me the big sun. I want to analyze that for like 30 seconds.
Can you show me, but can you explain to me how this looks like the sun is shrinking? Because this is like completely different exposure. And when you're exposing something, when you're overexposing something, like you see the sun right here, look, at this point, the sun looks huge, right? But when the clouds come above it, you can see that it's just this tiny dot, right? Wait a second, one second. You see?
Because there's more medium in between you and the sun.
So
there's more medium.
Wait a second. Unless you expose the sun the same way on this picture here, right? The same way, not one just dim and red and one overexposed, then you cannot compare the size. You should use a solar filter if you want to compare sizes.
So Day, is the sun moving away from you? Is the sun moving away?
No, the sun doesn't move away.
The sun doesn't move away. Okay.
No, it doesn't. You can see that it's the same size. Here and there, it's the same size.
So the sun's moving in the sky, or no?
The sun is moving in the sky relative to us because we are on a sphere that is turning. Just like you can see here. Okay, if you look behind the Earth, let's go behind the Earth.
I don't want to see your computer generated images. I don't want to see
you're
your
showing us. You're showing
This shouldn't
us
be allowed. This is fake.
You're showing us a cartoon, dude. Come on, man. That's
it's not a cartoon. It's a 3D model.
I was supposed to have time. I was supposed to have time.
Model. I can show you this in real life with a
it's a cartoon.
With the same.
It's a cartoon.
He might not have time, but I object to the objection about CGI. He's just demonstrating a concept. CGI can demonstrate a concept. There's nothing wrong with that.
So my problem with computer generated animation, okay, is that you input data, you input numbers until it works. So let's move on from the CGI bullshit. I want to see
what is wrong with this, and then you can tell me what's wrong with this.
Hold on, Day.
I just said that I do not believe in computer-generated things because you can make a computer make pretty much anything you want as long as you input the data that you need it to do. It will tell the story you want to tell. Anyways, let's move on. Let's move on. Let's move on.
Since we're off this topic, I'm gonna go to the next. And by the way, thank you
Hold
all.
on, Globe Denier. Digging for Truth didn't get his time on that. Or did you? I didn't think you did.
He said he's ready.
I wanted to see his big sun because in that video that he pushed of the big sun not changing side and the half sun, right? Okay, you can see that one part of the sun at one point when it's going away, the top of the sun disappears before the middle because there's so much medium. There's also refraction to get into that. That's the same effect as a supermoon.
Small amount of refraction here.
There's a refraction everywhere. It's the same effect as when you see a supermoon. It's the same effect as when you see a supermoon. You know what a supermoon is? When the moon appears to be like half the sky. It's the same effect. It's all about refraction at that point. And refraction, you're seeing basically the reflection bigger because the medium is denser and there's more interaction of the light with the medium. That's refraction. That's all I wanted to say.
If you can show me that the moon goes larger when it sets, as you just described, then I'll believe you. But the moon changes sizes only twice a month because of the orbit of the moon.
It's called a supermoon.
I've seen moon, affected by the Atmos that look big, but when you put a camera to it, it looks small. So that's to your eyes, it appears bigger. The sun's light is a lot brighter. That's why you still see the effect. You still see the effect of refraction because the light is brighter. There's more light density in the medium. With the moon, there's less light in the medium. But to your optics, you can see a supermoon in the sky looking super big. If you've never seen that, I'm sorry, but it does happen.
A supermoon is when the moon is closer to Earth, and it's a full. And when
it doesn't happen every single month.
Wait a second. When it's closer to Earth and also a full moon, that's called a supermoon. because sometimes it's closer, but it's not a full moon.
So speaking on the moon, hey guys, I'm gonna transition here to the next topic since we're talking about the moon. Okay.
Right.
So if this question is going to be for the flat earthers, okay, and then the globe guys can follow up. All right. So how do tides work on a flat Earth? This question's for Digging. You're muted, Digging.
Oh my God! I knew I should have studied Shane St. Pierre more, but so to my understanding of what I've looked into Shane St. Pierre and other people that talked about tides, it's all about like there's tidal nodes. Oh man, I'm not really articulate on that. I think Mike might have better, but to my understanding, okay, there's a lot of variable you need to take in consideration with the ocean current magnetic field that are being measured. In our model, the moon is magnetic, and it does play with that. The sun is also. Man, I can't articulate it like anyone else. I'm not good enough, and I'll admit I don't. I've done my research, but I can't articulate it right now because it's not in my brain yet. Like,
Mike, you wanna follow up with what anything?
Yeah,
Biggie's
yeah.
saying? You got about a minute and a half.
For sure. Yeah. So we all, I think we can all agree, whether it's the globe model or the flat Earth model, that we've got an electrified atmos, right? We've got electrostatics and electromagnetics that happen within our. I'm gonna call it. Can you guys still hear me? I'm just looking for a picture.
Yeah.
Yeah. Okay. So, and we've got this charge that's happening in our world, and this is the charge that our compasses are attracted to. So, for me and the explanations that I've seen, and the sorry, I'm fucking not finding this picture here, is that we've got salinated water is where we witness our tides from, right? We don't witness tides in fresh water unless the fresh water is close enough to a saltwater source that it's actually hydraulic pressure that's causing the tidal effect in a non-salinated water source. But it's our electrical current mixing with this salinated source and grounding with the ground that is causing these churning effects. This is why we've got I'm not finding the picture, sorry guys. This is why we've got areas that have no tides, and this is why it happens in ebbs and flows, because you can't have the way that it's explained on the globe model, that it's affected by the moon, doesn't make sense, and they keep changing how that is on their model, which begs the question, why do they keep changing it? We keep being told it's settled science, but as far as I understand, it has to do with the electrical current running through our world and how it's affected the salinated water sources.
Okay. I got a follow question for Day Day and Peter. So with obviously on the globe model, the claim is gravity affects the tides, correct? If gravity affects the tides, why is there some places on Earth where there's no tides, and then other places on Earth there's 3 and 4 tides a day, or I should say up to 4 tides a day? Can you guys explain that?
I have not studied tides in detail. I'm pretty sure it has to do with fluid dynamics, and I just also am pretty sure that Mike Guyver doesn't understand it because he said it doesn't work, but I don't think he's studied it either. Or at least if he did study it, he studied it with a robotomist bias.
I'm going to request a response for him when he's done.
All right. Yeah.
Can we let Peter finish?
Day Day, do you want to follow up? Do you have any follow-up questions?
Yeah. So tides are pretty simple. Okay. First of all, just
give me one sec, buddy. Hold on. I'm gonna put you on the big box.
Cool. Thanks.
All right.
So first of all, just to talk about what he said about electrostatic, it would be very, very simple to conduct an experiment to see if electrostatic is what causes tides, right? You could float water, for example, with just an electric charge. Just charge it or charge whatever it is below it, and then the water will float, right? If it's electrostatic. And nobody has ever done this, okay? So tides work like this. There are two tides. The tide that is caused because of the gravity of the sun, and the one that is caused because of the gravity of the moon. And sometimes there are combinations between the two. For example, this is called the spring tide because it's a combination of the gravity of the sun and the moon together. So the bulge is bigger. Same for the other side. And when it's when it's in the sides, so it's gonna essentially it's gonna become smaller because there's just the gravity of the moon and not the gravity of the sun. But the fact is that the sun still pulls the oceans that way and the moon pulls them that way. So it's like some of them go here and some of them go here. So you ask why sometimes there are four tides, and this is exactly the reason, because sometimes the moon is here and the sun is here, so there is tide here, and then because of the sun there's tide here and tide.
I'd like to rebut.
So yeah, go ahead.
Okay.
Digging.
So what Mike said is that in the same region you can have up to 4 tides a day in the same region,
Yeah.
right? Okay.
This is Antarctica, so the Earth is rotating, right? So if you live here, for example, so look, 1 tide, 2, 3, 4. You understand what I'm saying? This is like the pole of the Earth, the axis of the Earth.
Everyone would have every place would have 4 tides. Even not a non-salt water would have tides in the same. It would be a linear effect. If the forces would need to be equal, but the forces are never equal. Also, tides never follow actually the moon. It's always around 45 degrees from the moon when they start activating. So why is it always 45 degrees from the moon? Also, in your model, you have two different tide models. You have the dynamic tide models and the classic gravitational tide models. You're not explaining all the forces in your models either. I could steel man probably.
I only had 20 seconds. Do you want me to explain everything in 20 seconds?
You know,
it's impossible.
The other thing I wanted to say,
the fact of the matter is that essentially the Earth rotates into the tides. So if you're standing here, right?
Yeah.
And you move into this tide, and then you move into this tide, the small one, and then you move into this one, and then you move into this one. And there's lag because the oceans they're really big. It's a big mass of water, so it takes time for them, to.
Okay. I'm gonna give Digging 30 seconds to reply. Hold on.
I'm just gonna help both sides at this point. The tide is a big thing, and it's a big topic, right? So I do not think that we could ever explain both sides. Could make their full arguments because there's so many variables when it comes to tides. In both models, there's many variables. And I don't think it's a topic that we can only explain in like 2-3 minutes. I think Deddy would agree that he can't explain his tides in 2 minutes. He can make a general thing, but he cannot go, and we would spend like 4 or 5 hours debating tides. We can agree to that, and we could move on to another topic because there's so much information in tides.
No, I haven't had a chance yet. I'm being patient.
Oh, Mike hasn't had a chance.
No.
If he wants to take a 30 seconds or a minute, and if we all agree to that, but I do feel that tides are a lot of information, and I agree with Deddy. We don't get much time in this type of debate. Just saying.
All right, Mike, I'll give you a minute, and then we'll move on to the next topic.
Okay, so firstly, Peter, let's keep it cordial. I don't appreciate you strawmanning me like that. You don't know what I've researched and all that jazz, and you yourself are like, I don't know what it's all about. So let's not do that. Let's be fucking gentlemen here. How do we have a high tide on the other side of the Earth with a new moon on this side of the Earth? That doesn't make sense. Why do we call it a sphere or oblate spheroid if we've now got 4 lumps on the Earth like this, right? And if that's hold on. Oh, no, I don't want the no. Let me cook for a quick minute here, please. Daddy, thank you. Okay, so the other is Daddy had mentioned that there was never an experiment done regarding the theory that I had mentioned. That's incorrect. That's exactly why I believe that this is the way it's done. Before this experiment that I witnessed, I would not have a theory. I'd straight up be like, I don't know. Can we go to the next one? Because you guys are going to cook me on this one. But I did see an experiment using salinated water and voltage, and it does exactly what we would appear it to, or what we would witness it to do on our flat realm, right? We've got tidal nodes here and there. We've got some spots where we've got more than 2 tides in a day, and we've got some spots with no tides in a day. So that tide experiment does work. And lastly, 9 out of 10 tides do encompass the North Pole. So I don't understand what you're saying, Peter, that from a bird's eye point of view, we're seeing these 4 lumps on a rotating Earth that we're rotating into this water tide. So with that, I'm gonna mute. Thank you for giving me a chance to respond again.
Well, while we're on the topic of Earth's rotation there, Mike, and you brought that up, we're going to talk about that is going into our next topic, okay? So
I'm going to have some notes for you after this, Globe Denier, about how to run a debate.
Yeah, no problem. It's my first one. Like I said, I'm trying to get everybody a chance to talk, all right? So this next question is going to be for Team Globe. We'll just go to Peter because we haven't heard from you in a while. If Earth is spinning, why does it feel so stationary? Why can we not feel movement or measure movement of Earth? Why is there no experiment?
Why would you? I mean, there is an experiment. There are plenty of experiments to show that the Earth is rotating, but you're talking about bodily sensations. That's not the same as a scientific experiment. Don't conflate those.
Can you provide a scientific experiment using the scientific method that proves the Earth is moving in at 1,000, rotating while moving around the sun and moving through the Milky Way? Because Earth is moving allegedly in like 4 or 5 different directions all at the same time.
Okay, those would not be the same thing to measure. So are you asking for one experiment to measure multiple things, or are you asking...
I'm asking, is there a scientific method experiment that you have done that proves the Earth is moving?
I have not personally done an experiment to prove that the Earth is moving, no. But I have read about people who have, and I've probably talked to some on TikTok here.
Okay.
You see how this train moves? It moves at about 350 kilometers per hour. But you see that nothing here falls down or moves. That's because you cannot feel speed. You can only feel a change in speed. And because the Earth is in constant motion around the sun, and in constant motion rotates around itself, which is very slow compared to its size. Like the amount of rotation is,
Day, have you done, Day, you're showing us a train moving. How do we know the Earth is moving? What scientific experiment have you done?
If you would close this window, how would you know that you're moving?
So you're saying that we live. So you're saying we live in an enclosed environment?
No, I'm saying that you expecting to feel the movement is wrong.
According to the model of heliocentric model, we're on an elliptical orbit, and the Earth is speeding up and slowing down around the sun.
No, it's not speeding down and speeding up and slowing down because gravity is the curvature of space-time. So you're essentially in free fall towards the sun, just as the astronauts in the ISS are in constant free fall around the Earth. They feel zero gravity because they are constantly falling towards the Earth. It's only that the curvature of Earth curves at the exact same rate as they're falling, so they never hit the Earth. It's like, imagine yourself throwing a rock, right? And then throwing it faster and faster. So the track or the direction that it will go, so instead of falling immediately, it will fall a little bit further and a little bit further. And if you throw it fast enough, you will throw it so fast that it will fall the exact rate the ground is curving, and will keep on falling.
Okay. Have you personally done an experiment that proves the Earth is moving?
Have I put something into orbit? No. Sorry about that.
Have you with your own 2 eyes seen the Earth moving?
I'd like to point out this is another red herring on the topic of the shape of the Earth. Yes, it does pertain to space science, but space science is a red herring because, again, everyone who was educated knew the Earth was a globe for thousands of years before any space science began.
Okay, I'm gonna give Digging or Mike 3 minutes to respond to that. How do we know the Earth is moving, guys, or is the Earth moving at all?
The Earth is not moving. It's to our perspective. Basically, there's two valuable position when you're looking at the sky, right? So when you're standing still and looking at the sky, there's two options: either the sky is moving, or you're moving, basically. But there's no like when he was showing the train right there, right? That's they call it inertia. So basically, you're inside a container that's moving, and you only feel when it's accelerating, when it's going at a constant speed. You won't feel it unless it stops or accelerates more. That's what he's talking about. The thing is, someone pointed out that there's multiple motion, and it's an elliptical orbit. And your model states that there is an acceleration and deceleration in the celestial motions. So we would feel something about those celestial motions, and we don't. We cannot feel them, we cannot observe them, we cannot calculate them. There's nothing that we can do on the surface of the Earth to prove that we are moving. It's a theory.
I can prove to you why you won't feel this acceleration. Okay?
You won't
jump if you will jump from a cliff, you will feel zero acceleration. If you would jump,
Hey, hold on. We were given 3 minutes. We should get that 3 minutes.
You got another
You
minute.
should jump in after.
No, like, I don't know. I don't care. Like if you decide.
We're having a structured debate, bro, and he got 3 minutes. We got 3 minutes,
Oh,
not
sure,
you, though.
sure. Yeah, so forget about it. Okay.
Okay, so I'll respond to your points. Have you ever jumped from any height in free fall? I have. I went to Vegas. I went to the stratosphere. I went to the stratosphere, which is a 855 drop, and there's just steel cable holding you. I have felt the acceleration falling down. I almost fainted from the acceleration falling down on a free fall. So you do feel it. But yeah, Mike, if you want to take on, if you got more to add, go ahead. But yeah, you feel when you drop, you feel.
I want to prove to you that you're wrong. Okay, you left me the chance to prove you're wrong.
Day, I'm gonna give you 1 minute, Day. Then I'm gonna give Mike a couple minutes.
No, he can go. Just as long as you'll give me the chance to prove it. Okay.
All right, Mike, go ahead. You got 2 minutes, Mike.
Thank you. I'm trying not to be the squeaky wheel here, but I do want to turn to speak. Okay, so I've drawn a little diagram. See, this is kind of like we're moving in a oh shoot, is this gonna work? In a lineal movement. This is like our sun is like
turn off your background picture. If you turn off your background, yeah, turn off the background.
No, I prefer not to do that. I'm in the middle of a move. I don't need you guys seeing my junk.
Your picture phasing it out.
I'll just keep it against my chest. It helps. Okay, so this line represents.
Mike, you're cutting out.
Yeah, you're frozen.
Oh shit. Mike, you're cutting out, buddy.
You're completely frozen.
Sorry, can you guys hear me? I just said I had poor connection.
Yep.
Okay, the thing about it that I have a hard time with is that we've got this star, right? That's supposed to be, if we can imagine that this is our Earth, we've got this Polaris star that's supposed to be directly in front of us. Say we're traveling in this direction. This Polaris stays with us directly in front of us and never wavers from that throughout our orbit around the sun as we're blasting this way through this ever-expanding universe that started from a freaking explosion, mind you. We won't even get into that. And then on the tail end of it, you guys want to claim that there's a celestial body that's also in line with this that was a result of an explosion. I don't know about you guys. I spent some time blowing some shit up as a kid as a little bit of a young adult because of my profession, but things don't work that way in an explosion, right? You don't get lineal things that stay in line throughout millennia. So that's like the biggest thing for me. You know what I mean? We do, in your model, we do change direction and speed. There's multiple different orbits that are happening at the same time. And some of those orbits aren't perfect circles, they're elliptical. So when you get to the peak end of that elliptical orbit, there would have to be a larger gravitational pull. And depending on where you are in the Earth spin of that elliptic, right? You could be on the inside of the Earth spin as you get to the end of the elliptic as it's wrapping back around, right? Everything's going to feel different. It should be measurable. So
It's not.
what we
I can
do
prove
feel
it.
and what we do feel and what we do witness is no movement, right? Otherwise we would see that and we would be able to test it and feel it. So what we can see is a lot of these monoliths around the world that are aligned with Polaris that have never wavered, and they're still accurate to this day. So that's the point I wanted to make.
Thank you, Mike.
If I may, I don't mean
Yep.
to step. I don't mean to step on your toes, but as far as movement goes, it's irrelevant to the shape of the Earth. We're talking about. It doesn't matter if it's geocentric or heliocentric. The shape of the Earth, doesn't matter in this case.
I disagree. I disagree. I disagree with that. I disagree with that because the entire premise of the globe Earth is that it is spinning and moving. If there's no movement, there's no globe Earth.
Yeah,
That's false, but we can entertain you.
So, can I go now? Yeah. So, first of all, just put me on the big screen, please. Yeah,
Yep.
we know this picture. That's okay. So, first of all, I want to ask you just to see if you know what gravity means. When you're standing on the ground, what accelerations do you feel? You feel any acceleration?
Are you asking us? No, we don't feel like we're moving at all.
So you actually do feel acceleration. I'll tell you why. And I'll even give you a thought experiment to understand what I'm saying. When you sit in a car and you accelerate forward, what do you feel? You feel the back side of your body, right, getting pressed into the chair, right? Right. So if you lay on the ground, back first, all right, you feel the same pressure that you feel as if you're accelerating forward, meaning that when you're lying on your back, you are accelerating upwards. And this is what the curvature of space-time does. Gravity, instead of pulling you down, it's causing the ground to push you up, okay? The curvature makes you free fall towards the Earth, and the gravity stops that free fall, and you are constantly accelerating upwards. And if we want another proof for that, then this is a phone with an accelerometer, right? It shows the acceleration of Earth, like when you see that I'm pushing it forward, it's increasing the acceleration up, right? But now watch what happens when I throw this from my hand. Watch what happens to this chart the moment it leaves my hand. 1 second. It'll be in slow motion. Did you see that the chart went to 0 the moment it left my hand?
I saw it,
Watch
yes.
this again. Watch this again. The moment it left my hand, the acceleration went to 0, because in free fall, you aren't accelerating at all. You're free falling towards the ground. The only thing that accelerates you is the ground itself when you are standing on the ground. Right now, when you're sitting on your chair, you're constantly feeling the 9.8 meters per second acceleration upwards. This is the curvature of space-time. That is, by the way Einstein thought of it. He thought of this thought experiment. If you are inside a closed elevator and you are falling towards Earth, would you even know that you're falling, or are you just going to feel like you're weightless inside an elevator?
So, Data, you explained a theory to us, the theory of relativity,
Showed evidence.
Right? Huh?
And showed evidence.
Right, but that's not evidence the Earth is moving. That's evidence that the phone fell out of your hand.
We're speaking about gravity, okay? So think about this again for a second. Think about you accelerating in a car. Think about you accelerating in a car. The acceleration makes you go back, right? You feel your back pressed against the chair, just as you would if you would lay on your back. You will feel the ground pushing you upwards, right? This is the acceleration that you constantly feel due to gravity. It's not because of density. It's not because of anything that's pulling you down. Ground accelerating is accelerating you upwards.
So we're going to talk about that. We're going to go into the next subject since we're on motion of the Earth. Mike, this question is for you. can you tell us what the Coriolis effect is and how that works on a flat Earth or a globe Earth? About 3 minutes.
3 minutes.
I
Oh, I
think
need
that
30.
the host here is giving the flat earthers all the softball answers and like kind of giving straw men to the globe earthers. I don't feel like this has been a fair debate as far as the questions.
Peter, I've asked your questions that you asked me to ask. I've asked questions that literally globe earthers asked me to ask the flat earthers.
Yeah, but why are you asking about the globe model to the flat earther? I didn't ask you to do that. So who decided that?
Peter, he asked about both models, bro. He asked me to explain.
I'm going to ask you the same question.
I've never once been asked how the flat Earth model works.
Do you want me to ask you first, Peter? How does Coriolis work on your model? Do you want me to go that route? How does Coriolis work on the globe Earth model? If the Earth is spinning, right? That's your guys' claim that the Earth is spinning, right? Well, how is it that when we throw balls up in the air, there's no deviation of anything moving? Why is that? If Coriolis is a thing,
why? That's not how it works.
So how does Coriolis work?
The question contains a straw man in the way it's worded. You see what I mean? It's
how does Coriolis work on your ball? How's that? Is that better?
The Coriolis.
But, I mean, look, the Coriolis effect is there, and we can see that even snipers
I got a better one for you. Okay, how
they
does
have to account for the Coriolis effect?
How does the
You're saying that throwing the ball doesn't.
Please explain the Coriolis effect and how it works on a spinning ball Earth.
Yeah,
how about that?
Yeah, I'll show you how it works. Okay.
I would love to answer this though if I do get a chance to.
Oh, I'm sure you would, Mike.
Yeah. One second. I'm trying.
Peter, you neglected to want to answer the question. He gave you a chance, bro.
Okay, this is a good example. Let me just open this image. So when you shoot something and something is rotating, then the straight path becomes curved because the object wanna just keep on going the way it was shot, right? But you keep rotating. So this is the Coriolis effect, and on a sphere it's a bit more complex, but it goes something like this. This up. I mean, you can see videos of people doing this on a merry-go-round, like when they throw balls at each other, and you see that the balls, instead of going to the one that you shot at, it goes to the right or to the left. But on a sphere, it's a bit more complex, but it's the same effect. Maybe I'll find that video. You can keep on talking in the meantime.
Peter, do you want to add anything to that for the Coriolis?
I don't have. I think Daddy will probably do a better job explaining Coriolis than I will. But I was simply interjecting that it seemed to me that the questions had a bias in the way that they were designed and given. That's all.
So you see how when he threw the ball, when they're not moving, it went exactly straight to her, right? So now watch what happens when they rotate the. Oops, I misshot. So watch what happens now. They're spinning them, okay? The camera spins with them. You saw when he threw the ball away, it went like this.
So why don't we observe that in reality, Day?
We do, and as I said, snipers has to take into consideration the Coriolis effect.
Have you ever shot a rifle before and proven that true?
I have. I actually was a sniper in the army, so I know that we have to account wind and Coriolis effects.
Wind and Coriolis effect.
Yeah, of course. So you're asking why when I'm throwing a ball at the air it doesn't affect, because like this the effect is very negligible when you throw a ball, but when you fire a sniper rifle, it was a 0.5.
I got a question. Is it only bullets, or is anything in the air affected by Coriolis? Was it only certain objects?
The effect is negligible if it's not far enough. So the 0.5 bullets that I've shot could go up to a mile. and that's when you have any meaningful effect of Coriolis.
Okay. Peter, do you have anything you want to
Who's
add?
the gentleman in that movie that Bradley Cooper played? He played a sniper.
I don't know.
Chris Kyle?
Chris Kyle.
Yep. Yeah, he had an interview where he said he specifically adjusts for that.
I'm gonna make a statement on that. I do believe that Chris Kyle is a great person. He's an American hero. But when you're collecting a paycheck from a government and they set up an interview for you that's pre-screened, you're gonna tell people what the government wants them to hear. That's my opinion.
I just told you myself, like he just verified what I said, but I told you myself that I have to take into consideration
Yeah, but you don't say that when he's on the battlefield and he's fighting for you.
No, I'm just okay.
I was a marksman for a very long time, and you're full of shit, Daddy. And so was Chris Kyle, and he was called out by his own brethren.
Not a sniper. It's completely different. Marksmen shoot to about 300 meters stops.
No,
dude. We went out to a mile, bro.
Hold on, real quick.
And your .50 rifle is going to go much further than 1 mile. So if you did shoot a .50 rifle, you don't even know its own capabilities, man.
So please like and share the live. So my question is this, Day. You say
wait a second. I carried it on my back for 3 years, so trust me, I know exactly what it's capable of.
All right, so
much further than 1 mile. What's your MOS? I don't believe you.
How far is a bullet in the air? Like, if you shoot a bullet 1 mile, how many seconds is it going to be in the air for?
I don't remember.
Okay, so if it affects a bullet, why doesn't it affect a golf ball or a football or a helicopter or an airplane or anything like that? Is it everything in the air or only certain items?
What do you mean? Yeah, everything. But again, it needs to go far enough for this effect to not be negligible.
So it has to go far.
The Coriolis effect applies to things that are moving laterally with respect to the ground. It does not apply to something hovering in place over the ground or something that you toss straight upward and it's going to fall back down. It doesn't apply in those scenarios. It's a clear straw man of the Coriolis effect.
Okay. Daddy, can you state at what distance it isn't negligible where we do have to start taking into account?
So as I said, as a sniper, you have to take this into account when you're shooting into 1 kilometer. I'm saying miles because I know that you guys know miles, but for me, I'm from Israel, so we use kilometers.
We spend so much time.
So at 1 kilometer, that's when you start accounting for Coriolis?
Yep.
All right, I'm gonna give Team Flurf here a chance.
17 years since I've shot the sniper rifle, so this is what I remember.
All right, Mike, you got a couple minutes to respond to the Coriolis.
Okay, so my experience, yeah, you're right. I did not serve in the military. I almost did. I was way fucking smarter than that. I did not want to become part of the meat grinder. But I did shoot for Team Canada. I was a marksman for over a decade. I've been instructing since in one way or another for over a fucking decade. And I shoot in multiple different disciplines, not just target rifle. But we do shoot out to 1 mile, not just 1 kilometer, right? And your 50 caliber rifle is way more capable than 1 mile, is what you said. It's that firearm is effective to way further than that, right? So what I accounted for when I was in my discipline, what I shot, we account for windage, we account for bullet drop, we account for bullet coefficient and bullet drift. Sometimes you have to account for things like humidity in the air, or if you've got weather like heavy rain, right? Those are the things we account for. We don't account for Coriolis. Otherwise, the biggest teller, the reason why you would know that snipers don't account for Coriolis is because if they did, the most simplest instrument that we would have on every scope or even every rifle would be a bloody compass, wouldn't it? Because we would have to know what direction we're shooting. Because if we're shooting in a direction where Coriolis doesn't matter, then we wouldn't even account for it. It'd just be a quick look up to the compass. Oh, it don't matter, right? And then we would continue on. If it did matter and we were off into a direction where Coriolis was starting to affect our our bullet placement, right? Then we would have a table that would have to drift and continue more and more and more. You would have to account for it more and more and more as you aim into this Coriolis effect. And as you aim out the other direction, there would be a table, right? Snipers would have this, or myself, I would have this, because our ranges, we fire in every cardinal direction, right? We don't walk onto the range with a compass, bro. We walk onto the range with our charts, right? And our distance charts, right? And that's what we account for, and windage. But there's no Coriolis effect. It's never been measured and it's never been accounted for. That's where I'm gonna end with that. It's a complete fallacy, and no one's got proof of it. If you got proof of your calculations for Coriolis, I would love to see your shooting charts, but I don't believe that you've got them. I don't believe you have shooting charts, bro.
So I know that you sometimes don't know things, and that's okay, but line is like very low, okay? So marksman shoots 300 to 600 meters, okay? And snipers shoot.
I call myself a marksman because I wasn't shooting at human bodies.
Wait a second. You have videos of people shooting, showing you how the Coriolis effect bullets up to 10 up to 1,000 yards.
I would love to hear the figures, bro. You want to call me a liar? Let's show the figures.
No,
someone shooting a rifle and saying they account for Coriolis isn't proof of shit. You're lying.
Knows that. It's basic
You're lying.
information.
You're a liar.
Whatever. You people, trust whatever you want to trust. You can go on Google.
Dude, I got trained by some of the best people in the bloody world, and not once did they tell me about this Coriolis. Hold on, I shot for Team Canada. You think that they would inform me about this Coriolis, right?
It's irrelevant. You shot too short. That's too short to take it into consideration.
You're straw manning the distance I shot at.
But I just
I didn't shoot at a human body means I didn't go past 300 meters. Is that what you're saying?
I just showed you that marksmen shoot at 300 to 600 meters.
This is on Chat GTP, bro.
Mike,
interruptions. I'm gonna interject, guys. Hold on here.
Interrupt to anyone that calls me a liar, bro. I don't care.
Doesn't matter. We agreed on no interruptions.
Right, guys. Hold on. Slow down. So,
He started it, bro.
You can't.
Okay, are you fine?
Day, I'm gonna interject here. So in my experience of doing this type of research and looking into things, just because it's written on paper or you read it on the internet doesn't it doesn't mean it correlates to reality. Okay. I understand what the internet says, but I personally know dozens of people in the military that I went to college with and hung out with my whole life. I asked them about Coriolis. Not a single one of them said they ever used it in shooting any rifle or any distance. Not one time. So I know
because I have been in the military.
Okay, so again,
for 20 years.
Show the numbers. Show the proof. You can't just say you did it and not show proof.
What do you mean? Which proof do you want me to show you?
It seems. I'm just gonna throw this out there. If you're looking at a target and that target is 2 or 3 miles away, right? Are you honestly gonna sit there and look at a chart and figure out where you are on the Earth, exactly what the movement is of the Earth?
Absolutely.
Right, and then factor in.
Chart, bro.
Hold on, and then factor in wind. So you have to factor in direction. You have to factor in wind, humidity, bullet, the velocity, all of it.
That's why you have, I don't know how it's called in English, but that's why you have the second person who does that for you. Snipers always go
spotter.
in pairs. Spotter, right? Yeah, I'm sorry.
Well, not always, but yeah.
Here came to debate with the hosts as well.
Because
no, I'm just asking, because
and the as good as he is.
Daddy, show your proof, bro. Show your proof.
What again? What
you're making a claim and you have no proof, bro.
What proof do you want me to show you from 20 years ago?
Show me a shooting chart. Show a calculation chart. Show some numbers that says at this cardinal direction we have to account for this much, and that equates to this on your scope. Show that.
So okay, so I can't show you that, but anybody here can go and do their research and see if snipers account for Coriolis effect. Okay. I don't have proof from 20 years ago.
We're stating something and proving something are different.
Shooting charts from 20 years ago.
We're gonna go into the next topic out of that before this.
And Mike, to be fair, you didn't show any proof either.
Right.
Well, yeah. How can you show?
I'm actually legitimately looking for. So I'm in the middle of a move, and I'm legitimately looking for my box that's full of my shooting medals. I'll fucking cream you all, bro. I've got
I don't know.
Proof.
I
Medals are
don't
not
know if
proof.
you can
They
show
might be
proof.
that you were a marksman, but you
As-
didn't show any type of proof.
Proof of what? Proof that I did it?
An actual
Proof
shot.
of I think he's saying proof of the point that you were you
Do you want me to do a live with you guys? Do you want me to show you? Oh, I can't show you some of my implements that I do that with now.
Google and showed you that you shot only to 300 to 600 meters.
Buddy, I shot out to a mile. You're trying to nail me on your definition of a marksman. My definition of a marksman is hold on, shut the fuck up and let me answer the fucking question.
Stop, Mike, stop. You gotta watch the language. Please watch the language.
I understand.
You keep letting this guy walk on me, bro.
No, hold on.
Then shut him up and let me answer. Let me reply. This is bullshit. He keeps wanting to call me a fucking liar. I get lit up, bro.
Hold on, Mike. Stop. He's not calling you a liar. He's just asking
Straight
for
up
proof.
did multiple times. Buddy doesn't have proof of his claim.
Neither of you do. That's why we're moving on. Okay? That's why we're moving on. All right?
You want me to phone a friend right now? You want a third party voucher?
No, we don't want vouchers. We want proof, Mike.
We can't.
I'm looking for the proof, pal. I could shoot circles around all you guys. That fucking lying fool as well. It's bullshit.
I think. I
got a violation. I got a violation. Heads up. Quick. We cannot have firearms or weapons on screen. Thank you.
Right. You can't. Right. That's why we're not going to show firearms.
You know what's funny is because I saw somebody doing a live where they showed plastic, like AK-47s. They were selling toy guns. And you can't tell by just checking their appearance that they weren't real or fake. So I don't know why they're giving you a violation.
Deddy bailed because he knows being called out as a liar.
I bet that's not why, Mike.
Dude, hold on. I can't prove. I can't prove. Hold on. I can't prove that I didn't account for Coriolis, but he can prove that he did. I can't prove a negative claim, but he can prove a positive claim. Show me a chart. Show us all a chart. Show us all a table, dude. That's all I'm asking for. It doesn't even have to be his own.
I'm asking Day Day to come back up. Is he able to? I think Day Day had on his screen a photo of a pew pew. That's what happened.
Oh, that's what it is.
Yeah, that's what happened. I caught that. So maybe that's
I was going to show you guys my team shot, but it's not on my Facebook
yet Mike
account.
leapt to the conclusion that Daddy left because he was called a liar.
No,
absolutely.
He's still down there.
You know how many times people drop because they're getting called out? All the time, bro.
No,
Yourself included.
Day Day showed up.
I got a violation, guys.
This is what I want to avoid. Is Day Day able to come back up, Enoch, or no?
No, he said no. He got a violation, not allowed. If he has another account, he can come up with another account. But we can
give him a 10-minute or for the whole day.
Yeah, do you have a 10-minute, Daddy? Can you say that in the chat? Let us know. And please, moderators, don't mute anyone on panel. It's not your job right now, please. Globe Denier is taking care of it. And end of days, I still can't add you. Sorry, bro, but you've been doing a good job moderating. So
anyway, let's go on to the next subject. Peter, I'm going to give you this one, okay? Since you're anxiously waiting, okay?
Since I'm the only Glober left at the moment.
someone said you look like Quentin Tarantino sitting there. That's funny.
He does. That's who he was.
He does. That's what it is.
He does.
So, Peter, the next question is for you. Since we were talking about a spin of the Earth and whatnot, can you please explain to us how the seasons work on the globe Earth, please?
It's the axial tilt of the Earth. So the Earth, if this is celestial north, based on like perpendicular to the orbit, the plane of orbit, Earth is like tilted 23 degrees this way, and the sun is coming this way. So here, the North Pole is facing. Now the South Pole is facing the sun, and that's why the seasons work on the globe. Hopefully that was clear. I don't have a visual aid at the moment.
Yep, it was. I got a follow up for you.
In the process of moving also.
I got a follow up for you, Peter. How can you prove a tilt?
Was that clear?
How can you prove a tilt of the Earth? And you're muted, Peter. Sorry, I don't know how that happened, but Peter, unmute yourself. There you go. How do you prove a tilt of the Earth?
Prove the tilt of the Earth.
Yeah, how can you prove the Earth is tilting?
It has to do with the Um, the, I would not use the tilt of the Earth to try to prove that the Earth is a sphere. Okay, that's getting things the wrong way around.
You claimed
There
that
are
the tilt of the Earth does your season, so you need to prove the claim of the tilt in order for your explanation of the season on your on the globe to be valid. That's what I'm saying.
no. I answered a question that was asked about the globe model.
And
That
I
I was
gave you
not
a
asked to give a.
and I
I
gave a
was not
follow up
asked.
question.
That was going to be my follow-up question as a rebuttal because you made the claim of the season being the tilt, but in order for your claim to explain the season, your claim is the tilt. How would you explain? How did you come up with the tilt of the Earth? How did you calculate the tilt of the Earth to come to the explanation of the season because of the tilt? That's my question.
I answered a question that was asked about the globe model. I was not asked to give proof for the globe model until after I gave the answer. Now I'm being asked how to prove the axial tilt of the Earth. Of course, proving the Earth is a sphere is much easier than proving the axial tilt of the Earth, although it can still be done based on the movements of the celestial bodies, the stars, and things like that. You know, if you take a star trail time lapse at night, you're going to see those star trails making a circle around the north. Well, I guess that is celestial north. I don't know the terminology because I'm not an astronomer, but the star trails are going to make a circle around Polaris, you know, the North Pole, and Earth's orbit around the sun is going to be tilted from that. If you do the math, if you observe enough, then you're going to find that axial tilt. I don't have a proof ready. I don't have an argument ready for that because that does not require, or that is not required for proving the Earth is a sphere.
No, but the proof of the tilt is required for your explanations of the season. That's why I'm asking, right?
No, if you can prove the Earth is a sphere, then you can start to build the argument that way. You don't get to dictate to me how I need to build my argument. I answered a question.
Okay.
All right, I'm going to follow up with the flat earthers. How do you guys explain digging? How do you explain seasons on a flat earth?
I need to restart my computer. I was outside, but basically, from my understanding, it's because of the analemma, which is basically the sun traveling between the Tropic of Cancer and the Tropic of Capricorn. We can see that the analemma by taking a picture at the same time every single day for a year. It will create a perfect analemma. In the north, the circle of the analemma at the top will be smaller because on the flat Earth there's less circumference of the let's say orbit around us, and during our winter in the north, the analemma is bigger. The circle of the analemma is bigger because there's more circumference in the south on the Tropic of Cancer, I believe, is the one down south, and the Tropic of Capricorn up, or they might be reversed. I'm sorry about that. But yeah, that would explain, since it's traveling between the Tropic of Cancer and the Tropic of Capricorn. There you go. He's got it. I was opening to get about the same image. So if Mike wanted to take a minute and a half, he's good to go.
Mike, you want
to? No, just to take up the last minute. Yeah, you bet. I'm just going to reiterate most of what he just said because we're in total agreement here. This is the example of our analemma and the movement of our sun. The moon has its own analemma as well, with its own precession rate. Here's the Tropic of Cancer, equator, Capricorn. This is likely not accurate. This is a depiction of. And as our sun goes around throughout the year, it raises and lowers. We can see that throughout our analemma and comes inward and outward, giving us our seasons in the center or in the north and the seasons in the south, right? This is why we get this 24-hour sun in the center and not in the south like they're trying to prove right now. But yeah, I mean, the rest of it is exactly the same. So yeah, and this is why, like, hold on, just to take up the last couple of seconds here, if I can. This is why we have a different, totally different climate in the south than we do in the north. In the ball model, it's supposed to be on an even tilt and sort of an even rotation around the sun. Thus, I don't understand why we don't have similar temperatures in the north and the south. That's a uniform, model. So, anyways, that's how it works on our world.
All right, Peter, do you want to follow up real quick, and then I'll introduce Fuzzy Bear?
Yeah. So as it happens, I actually was in the middle of making a video that I haven't finished yet, and this will probably help things. Can you guys see this?
Yep.
Okay, now this is to demonstrate a concept, right? Obviously, this is just a diagram, but this is Blender. It's a three-dimensional model, and all I've done is I've taken a perfect circle and a sphere that travels around that circle, and then I've taken the camera, and if I press play, both of them will travel around their circles, right? Now, if I go into that camera's view, hold on. Sorry, 1 second.
What are we looking at here, Peter?
There we go. Can you see what shape that's making on my screen?
It looks like an elliptical.
Let me rest my finger against the screen so you can see better. I don't have this compiled into something like to demonstrate yet, but it's making a figure 8 on my screen.
Okay.
If I rendered it out and made a composite, you would see a figure 8. The analemma is a consequence of the 3D geometry of the globe, and these flat earthers just used the word like 30 times in their explanation of seasons, but the whole concept is stolen from the globe.
So, Peter, I got a follow-up question for you. Why is the analemma larger in the southern hemisphere than the northern? Like how it looks in the sky with the figure 8, it looks like it's larger in the southern than the northern.
That's because of the eccentricity of the Earth's orbit, which is a very small deviation from a circular orbit that causes that figure 8 to be larger on one side.
Okay.
It's just 3D geometry.
All right, I'm going to introduce Fuzzy. What's up, buddy? Thanks for coming up. I appreciate you for stepping in for Day, who got a violation. You want to tell us where you're from?
I'm from the U.S. Northeast.
Northeast, nice. Well, my next question is going to be for the Globers. Can you guys give an example of a pressurized system next to a void or vacuum of nothingness, and how that would look?
Well, once again, I think similar to what Peter alluded to before, the phrasing of the question itself is a straw man. Right?
Why?
It is a misrepresentation of what is the actual globe model, right? You guys consistently tell us that you know the globe model better than we do. And yet you somehow think that we have this super high pressure system bordering right up against a vacuum. And that is not the way it works, right? We have a pressure gradient, and as you go up in atmosphere, every 100 feet you go up, there's a little less pressure. Every 100 feet you go up further from that, there's a little less pressure. A little less pressure because there is a little less mass. And as you get to what would amount to the boundary between Earth's atmosphere and space, it's already down to almost no pressure, right? So you're not sitting there with a high pressure system right next to a vacuum. What you have is the gravity of Earth holding on to its atmosphere, the the weight of the atmosphere makes the pressure higher at the surface of the Earth and lower as you approach the edge of space. So it's already a straw man to have to expect to have a high pressure system sitting right next to a vacuum. Now, what I would follow is in the laws of thermodynamics, how could you ever have a container of gas that doesn't completely equalize in that container? Right? You say that there's a firmament covering our Earth and containing everything in it, and yet you have no explanation for why the gas does not completely fill the container with equalized pressure, when we know full well that the atmosphere is a pressure gradient from top to bottom.
Okay, so we can't create an example of that here on Earth using the scientific method, is what you're saying, correct?
So it wouldn't be expected inside of the gravity of Earth, right? Because we live in the gravity of this massive thing called Earth. So it wouldn't be expected. What you can do is on the International Space Station, you can do experimentation that does not have to adhere to the Earth's gravity in their environment. And I have seen plenty of videos where they have balls of water. The natural tendency of water in space is to ball up.
Okay, so here on Earth, I'll use an example. If they're building a vacuum chamber, they have to build 12-foot concrete walls and steel barriers and have a massive door to be able to suck out all the air of this vacuum.
Yes.
For a perfect vacuum or void of nothingness to exist next to a pressure gradient, there has to be a container, right? So that's how the science
inside the gravity of Earth, inside the atmosphere, where the weight of the entire atmosphere would be pressing down on that container. Yes, that is true.
So
it
that's
better be reinforced.
Right. So that's the scientific method, is we have to be able to replicate it, experiment, test it, and reproduce it. But yet somehow that doesn't happen in Earth's atmosphere. Is that what you're saying?
You're asking us
I'm
to
saying
create.
that would not expect it to happen inside of Earth's atmosphere because
You're
of
asking
gravity.
You're asking us to create an Earth. We are not God. Right. What we do in order to study God's creation is not to recreate his creation, but to study it, okay? The repeatable science you're talking about works most of the time for studying certain things, but when you're talking about things on a grand scale, sometimes you have to step a little outside that and make observation and inference.
Okay. I'm going to give Mike and Digging a couple minutes to respond to them.
Mike, you want to start, or do you want me to? Because I was just going to say, like, when you were explaining the atmosphere pressure gradient, right? There's other variables out there that can explain what you so-called gravity, and that's the electrostatic potential as you go up higher. There's an electrostatic potential gradient that gains in strength as you go higher, right? And we all know that electrostatics have a force and apply forces on molecules on the quantum physics level of molecules and atoms, right? We know that those are bonded by electromagnetic forces, not by gravity. They're bonded together by electrostatic forces or electromagnetics. And there's a gradient of electrostatic potential as you raise in the atmosphere, creating a space in between the atoms because they're getting positively charged as they go in the atmosphere. So there's a space. That's why there's a pressure gradient as you go higher in our model, because our model has the electrostatic energy and electromagnetic to explain gravity. That's all I'm saying. And that can be measured. There's been tests out there.
So yeah, and you're not taking it into consideration in your model of gravity. You just put it aside. It's not. It's not there. It's not. So yeah.
And if I can just add on the tail end of that, the interesting thing is, so we can't have a gas pressure system without a container. We know this. Now, the question that's often posed to flat Earth is how do we have a gradient when we don't have an example of a gradient anywhere else? Well, the difference is like within a propane can or within I don't know, sorry, my language. I'm a construction worker, guys. I'm sorry for the language. I'm trying. But inside of like an oxygen bottle or something, you don't have an orbiting sun and a moon that's changing the heat and the properties of the molecules that are in that atmosphere, right? When we've got a huge pressure system inside of a contained dome, if we all want to just imagine for a quick sec how crazy that would be, that we wouldn't be moving and all this stuff. And if we've got a heat source in there that's heating all of these different atoms and molecules, it's going to change, just like we see in old school thermometers. I forget what they're called, but as these things heat up, they're going to start rising and other things will fall, thus we getting our weather and stuff, right? That's why we've got the gradient in here, but we can't have that pressure system without the container. It just doesn't work that way. And there's no way to prove it otherwise. So
And if I can add on that, you can create pressure gradients inside of a container, like water pressure with air on top of it inside of a container. That's two different pressure gradients. And like when you pressurize gases inside of a bottle, like it will become liquid because of the amount of pressure, but there will be a slight pressure gradient inside of it. Like it is possible to create pressure gradients inside of a container in many ways.
I don't even know what's going on anymore. I'm alone in here, and
No, Peter, we got you. Peter, we got you, fuzzy bear back, man. Sorry about that. Your day.
Hey, sorry, I got a phone call from work.
All right,
so that's understandable. But I mean, like, what is going on with the timer? What kind of calculus is that you're doing to figure out how much time each person has? And I don't know what I'm looking at.
I'm watching. I'm trying to have the total time because I told you guys I was going to limit this thing to like a little more than 2 hours, and obviously we're more into that. But just keep an eye on it while you're speaking. So you, like I said, if you're 17:30, give yourself 2 minutes to respond.
I mean, may I ask a question?
Of course.
You claim that we're in a closed system. Can you prove that? I mean, do you have any evidence of such container without saying that it has to be there? I mean, do you have a sample, a physical sample, photos, anything?
I'm not. I'll let Digging or Mike answer that. I'm not debating tonight.
Yeah, I'd love to prove it. However, I'm not allowed to prove it. We've tried to set that up. Hold on, sorry. Let me stop the speed. Yeah, and that's the same for the north, where there's a no-go area in the north and in the south. And as much as we want to argue that it does or doesn't exist, it's quite simply there, and it's the resources of trying to get there that are going to be the problem as well. We've got this the final experiment coming up, and it's big talk right now. But I have my own hypothesis on how that's going to go, and it's one of the reasons I think why flat earthers are skeptical about going out there. I don't know if you guys have ever worked on anything unorthodox like I have. I've been working on some alternative fuel sources. You think I'm going to be telling the world about those if they work? Fuck no, right? That's the same thing with this. They're not going to allow people to go prove that this is a thing, right? The powers that be do not want that. That's why we're not allowed to go prove it. But, however, there is some science right now that's very interesting because end of days, like I get the argument that like, well, how do you prove that there's a dome, right? Like, how does that work? But there's some new science about this O3, our ozone, O3 freezing at a temperature that's stated is that the outer space, the space that's outside of this dome is colder than. So then therefore it would be able to freeze, and duplicated in a laboratory, this medium is freezing a brilliant blue color, which is exactly what we look at in our skies. So if this is duplicatable in a laboratory and observable, we can do this with the scientific method. That could very well explain why when the Atmos is getting far enough away from this beautiful sun, why it does freeze. Just a thought.
I mean, when you get up to, you could always send up a weather balloon or some type of high altitude balloon, and nobody's ever, sent just like if you have a helium balloon in your house and it goes up to the ceiling, sticks there. I mean, a high altitude balloon can go up there and rest at the top of the dome if there's one there. Nobody's ever done that.
See,
No
but I
plane
don't
has ever
think
flown into it. No rocket has ever flown into it and blown up. There's no
that's right.
sample. There's no photos. There's nothing.
Well, I disagree. I think that Go Fast rocket kind of shows something a little bit different than what we're used to seeing. That, and from what I would hypothesize this would work, is that if there is a gradient there where you're getting further away from this heat source, there's going to be some sort of a slushing effect or an accumulation of what is ironically being referred to as a superfluid. Not just my wording. This is coming from the powers that be way up in NASA talking about a superfluid up there. And so I don't know exactly what's going on. I don't know exactly what's going on up there. Well, I'm talking about NASA talking about a superfluid and me adding in some logic about how freezing works, right, Peter? So
as in you taking it out of context.
Right. Thank you very much for your intelligent rebuttal there. So
Fuzzy
just to end with that, if we've got well, hold on. Let me finish. Let me just finish. If we've got a weighted object on like a balloon, I don't know that we would be able to get all the way up there because things do spread out. There is this gradient, right? I'm not sure if they would make it that far. It's too dense. So, and I don't want to get all biblical, but I mean, our world is not supposed to be measurable by us anyways. And I think that's why it's the temperature.
So a couple of rebuts to what Mike just shared. First of all, the ozone layer, right? It's called the ozone layer because ozone is in its highest concentration up there. But that's not to say that there's this layer of solid ozone or even dense ozone. It's 1 to 10 ozone molecules every million molecules of air, right? So it's a higher concentration than we have here on the surface of the Earth, but it is not a impressively high concentration of ozone. Secondly, the freezing temperature of ozone is minus 110 degrees Celsius or minus 179 Fahrenheit. The typical temperature of the ozone layer in our atmosphere is minus 60 at its highest centigrade, minus 76. So not anywhere near cold enough to freeze ozone. So none of that actually carries any weight scientifically as far as an explanation for what a firmament might be. It's certainly not. Whatever it might be, it's not the ozone layer.
So Fuzzy, I got a follow up to that, if you don't mind. Did you test any of that yourself, or is that just hearsay?
Did you test the existence of a firmament yourself, or is that just hearsay?
Well, I mean, if you want, I could send you dozens of government documents to talk about.
If you want, I can send you lots of scientific papers that describe the layers of our atmosphere, the temperatures we experience there, and the freezing temperature of ozone.
Right. So, do you think that's all possible?
So we're in the same boat.
Right. Do you think that's all possible?
The ISS sitting in our thermosphere like that?
Right. Do you think that's possible underneath of the firmament?
This is another element.
Do I think it is possible for the ozone layer freezing to be an explanation for the firmament? No, I do not. Not based on what we know scientifically about our atmosphere.
Okay.
Globe Denier, I want to point out this is another element of bias in the questions that you've been posing tonight. Every time you say, have you done this experiment yourself? That presupposes the flat earth position that most scientists are liars and therefore we can only trust science we have done ourselves. So if you ask us a question, how something works on the globe, and we give you an answer about something we've trusted someone else to do, that's a valid answer. We don't have to do all science ourselves.
Peter, actually, if you think about it, the default is a level topographical stationary plane because it's what we observe and experience.
Yeah, non-robothemist, by the way.
Right,
non-robothemist.
So the globe, the claim is the Earth is a globe. The default is that it's a level topographical plane because that's what we observe and
non-robothemist.
experience.
The default is that the sun travels underneath the Earth at night.
That
If you really want to argue that,
Time out. Now that's a straw man argument, Peter.
oh no, that's the default. You want me to prove it? Because I can. I came with evidence for that.
Your claim is now that the sun moves underneath of the flat Earth at night.
Could I interject for just a second? I do want you to prove
Fuzzy.
this.
Hold on, Fuzzy.
No,
I'm
I do
asking
want you to
Peter.
prove this.
Hold on, Fuzzy.
But here's
Fuzzy. Give me a second. Hold on, Peter. Just curious. What do you think flat Earth is, Peter?
You tried to claim high ground by introducing the concept of a default, okay? And I am challenging your concept of the default by pointing out your cosmology is not the default. The default is believing that the Earth is flat and the sun travels underneath it at night. All ancient flat Earth cosmologies believed that.
No, that is not true.
Yes,
that
is
not
true.
true.
I have evidence. I have evidence of at least one that I've studied that does that.
You've had 1 out of 50?
I haven't seen any that don't.
So do you think the sun?
Any that don't.
So wait. What you think the sun do you think the Earth, the flat Earth, is a disk in space?
No,
is that what you believe?
I'm a glober. Okay, I accept modern science.
Okay, but I'm asking you, what's your conception of flat Earth?
Robothemist or non-robothemist?
Correct.
Robothemist.
That's a valid question.
Robothemist flat Earth is like the sun traveling in a circle above the Earth.
Okay.
That's what all of you guys believe, right?
Correct.
That's not the default. Almost none of the ancient flat Earth models or cosmologies believed that.
Are you sure about that?
Sure. Pretty sure.
Can you look at the big screen right there?
Yeah.
The ancients the ancients understood that the sun actually set. It didn't far.
Yeah.
The sun
set.
That's the difference.
The ancients believed that the sun moved in the sky and it appeaed to set due to perspective.
The ancients had no concept of perspective. They
sure
saw a
did.
sun going down behind the curve, the edge of the Earth.
Every time that a robothemist such as yourself tries to explain sunset using perspective, you use a botched version of perspective that would have the ancient flat earthers would have been ashamed to associate themselves with such a nonsense explanation. Their model is better than yours.
I do want to interject.
Their model is better than yours.
I do want to interject just from a procedural perspective.
I'm just asking because this is the first time I've ever heard any glober ever suggest that any ancient culture that the sun went under the Earth. That's the first time I've ever heard that. And I've been
just look at Tablet
this.
9 in the Epic of Gilgamesh. The sun, they conceptualized the road of the sun as a tunnel underneath the Earth, and the sun went through it every night. And there's a whole scene where Gilgamesh travels along that road.
Can you even prove that Gilgamesh was a real person?
He probably wasn't. I'm just saying that the ancient flat Earth model of Mesopotamia was non-robothemist.
So do you see all these other flat Earth models on the screen right here? Were they
Half
all
of those are not even flat Earth models. I see a bunch of azimuthal equidistant projections
it's
there.
What it is. It's ancient cultures that knew or believed that there was a dome above the Earth and the sun and the moon were within the dome. That's
I'm not arguing about that.
Well, that's actually biblical cosmology as well.
Right, and then we learn science, and we learn things, and we realize that that's incorrect.
I need to interject and tell and explain to everybody that our moderator is arguing on one side of this debate.
Right.
At the moment, he's the one sharing his screen and arguing on one side of the debate.
Pointing out what ancient cultures were.
Pointing out, you were arguing on one side of the debate.
Actually incorrect. I can't even see you, Mike.
Yeah, I can hear you, Mike, but I don't see you in a box.
I don't see you in a box, Mike. Mike, do you want to drop and come back? You want to try that? Because I was kind of taking over for you right there. See if we can get him back.
Hey, Enoch.
Yeah, buddy.
Enoch,
Yeah, buddy.
are you still having trouble adding me as a mod?
It's not working the whole debate. I've tried like at least 10 times, but I'll try one more time.
There he is.
Okay.
I mean, I'm just saying, guys. Look, I've never heard of any ancient culture believing that.
Let's look at the Epic of Gilgamesh.
And study the
The Epic
Robothemist
of-
movement specifically. Study that from the late 1800s.
Yeah, because you are all part of it.
Learn where your roots come from. Learn where your roots as a flat Earth believer actually come from.
The Bible, actually, but that's just
they come from the
that's wrong.
Robothemist movement.
Okay.
No, the roots of my flat Earth belief comes from measurable lack of curvature.
You guys are just ignorant of history. Your movement did not come from Bible belief.
No, this movement's happening because of the scientific method, and we're able to prove things you guys can only prove with pseudoscience.
No, it started with Robotham. It started with Samuel Robotham in the
Well,
1800s.
however it started, it don't matter, because right now it's all about proof, right?
It matters. It matters.
It didn't start in the 1800s.
Yeah, it did.
What? No, I don't believe that it started in the 1800s.
It's
modern
it's
flat Earth.
verifiable.
You say it started in the 1800s. We don't believe that it started. We believe that it's.
Then show me one
modern.
person before Samuel Robotham in the 1800s who ever claimed that the sun travels in a circle above the earth and never goes beneath the earth. Show me one person who ever claimed that before Samuel Robotham, and then I will entertain your argument.
Putting it on the big screen.
I'm sorry to interject.
Those are cartoons.
Enoch,
Those are just
somebody,
drawings.
somebody in the
Cartoons.
comments mentioned that you need to remove a mod to add me as a mod.
All right, I'll try that real quick.
Okay, thank you.
So I'm gonna get back on topic here. Digging, do you have anything you want to add to that? Because I know you've been kind of muted for a minute.
Oh, I don't get what he's saying, because that, like, no matter what was said before, what we observe in reality is not what you're saying. So, like the tunnel and everything, that's maybe he taught that, but what we observe in reality, when I go outside, when I take pictures of distant objects and stuff like that, that's what makes sense to me, not the spinning globe. So, yeah,
We don't
even know what to say to that, because to me, the Samuel Robotham thing sounds. I'll agree with Peter that it sounds pretty ridiculous. I want to look it up, but it sounds pretty ridiculous. And from what I've looked into, there's models of a dome way before the 1800s, and yeah. So let's move on to something else, because this is just a plain circle, and it's.
I just want to remind us why that came up. The host was giving biased questions, and I pointed it out, and then the host tried to claim high ground by establishing this concept of a default. I'm pointing out that Robothamism, and that means all of your views are not the default. Okay, that's why that came up.
So you're saying our default that we stand for, the default is observable reality, right? Our default position is observable reality. That when you stand, you're not spinning. That the sky is moving around you. That's what he meant by default position. When you go
I know what
outside
he
and
meant.
no, listen, dude, listen. When he was talking about default position, he meant when you go outside and you stand and you look at the sky, your default position is you're not moving, the sky is moving around you. That's the default
And that the
position.
sun
That's
is below you at night.
Observable reality is the default position. I believe
The sun
that
is not below you at night.
The sun is not
It
below
is.
you at night. No.
It is observable reality that the sun is below you at night.
That's incorrect, and it's not provable.
That's the default position. That is
It's
the
not the
default
default.
position.
Hey, when
It
Deddy
is.
was up here earlier and he showed us that amazing picture of the sun, what I wanted to talk about, one of the reasons why I wanted to rebuttal on that is because if we froze it on the right time, we've got these beautiful crepuscular rays. How does that happen? 93 million miles away, 94, 92. It changes throughout the year, right?
They're converging parallel lines. I have a video about it.
Yeah.
But let me just
Converging
point out,
parallel
this is a
Yes,
failure
like train
of
tracks.
this is a failure of the host to predict how the
Unless
argument
you
was
actually-
going to go if he's controlling the topics. So, thank you, host.
I'm assuming you actually don't believe that railroad tracks the lines actually do end up meeting in the middle there, right? And stem from there,
I'm
right?
assuming that you know that eventually it appears as though those lines touch each other. They reach a vanishing point, right?
It appears, but they do not. So you can't judge the source of those crepuscular rays based on their having an appearance of meeting somewhere in perspective. You can't judge them.
That's perfect. And as that object is leaving that point of the vanishing point, right, where those convergence lines go, your object's going to disappear. Hence, the sun leaves our point of view.
That's nonsense.
It's not nonsense. It's observable reality.
It
That is your world, bro. You're just ignoring it. Yes, it is.
The sun observably stays the same size all day long.
The Mesopotamians
No, that's measurably false.
It never changes size.
It does change size, and it's been measured. There you go, bro. Look to your left.
Put a solar filter on it.
That is
the Mesopotamians.
They both have
the Mesopotamians who wrote the Epic of Gilgamesh were smarter than you, Mike Guyver. They saw the observable reality that the sun goes beneath us at night.
You're hilarious, Peter.
Peter, we can't even prove that
I love that you need to attack the person and not the fucking argument, right, Peter?
We can't.
This is a typical Globey right here.
We can't.
Can a light on the
You know what?
ceiling?
You're right. I'm sorry, Mike
light-
Guyver. I shouldn't have said that. You're right. I'm sorry.
You've been full of that passive aggressive shit all night, pal. That's why I don't like. That's why I don't like talking to you.
Can a light on my
Stop,
ceiling
stop,
ever make
please.
an upwards shadow of my couch? My 8-foot ceiling. Can a light on that ceiling ever make an upwards shadow on my couch?
If you move the couch further
My
away,
3-foot couch staying just where it is. Can a light any distance on the ceiling make an upward shadow
Yes.
on my couch?
Yes.
Yes.
How? Tell me how perspective works that way. Show me geometrically how perspective could ever work that way.
What would be better is if I set
geometry.
up an experiment to show it.
Show me the geometry.
So there's
simple geometry.
I know
Very
what
simple
experiment.
geometry.
I know what experiment you're talking about, and Rob Skiba did it, but I'm the host, and I'm not going to say anything about it. But I do want to go on to the next topic, which was a question for the Globers: is how did they prove the distance to the celestial bodies? Peter, if you want to grab that one.
Shape of the Earth, but we can entertain it because
It's a globe Earth debate, man. Look, again, flat
so
Earth.
what you're doing is saying that it's flat Earth versus all of science. Okay,
Right.
That's not a debate about the shape of the Earth. That's a debate about all of science.
Yep.
Right. Flat earthers
We can
always say,
talk
why are
about
we
that.
looking to the sky to judge the shape of our
Again,
planet? And yet your
Right.
questions are, how do you know how far the moon is?
This is your guys' claim that in your model all these things have to work. This is a question from a flat earther to a glober. I've asked.
Debating the shape of the Earth.
All right. Well, we can entertain it. I just wanted to point out it's a red herring on the shape of the Earth. That's all I was
Okay.
doing. So the question about how we
curvature.
Can I just say one thing? It's not a red herring because in your calculation of the distance of the celestial bodies, you pre-assume the radius of the Earth.
No, we don't.
Yeah, you do.
Show
You
me the
have to.
calculation.
No, we
Show me
don't.
the math.
No,
Show me
it's
the
not
math
true.
where you don't calculate. In order to, you need to pre-assume the radius of the Earth and to get the distance of the angles and stuff like that. And yeah, you just show me the math. I want to see you
that's
calculate
correct.
this. Yeah,
That's where I was going with that. Is in the globe model, you're assuming curvature of the Earth to calculate distance to the sun and the moon and the celestial bodies in the
Not at all.
sky.
That's
Not at all.
why we wouldn't use those as arguments for the shape of the Earth. You can't dictate
But
to
we
us
don't.
how to build our argument and then tell us that it's a circular
Really?
argument.
Because the first rule of like Globe Earth Club is everybody always says, well, the sun and the moon are circular in the sky, that must mean the Earth is a circle or a sphere too.
Okay,
I
did
never said
anyone
that.
make that
I would
argument
never
tonight?
say
No,
that.
but
I would
many
never
We
say
I
that.
observe
didn't.
all the celestial bodies as spheres. What are the odds that the Earth is not?
I would never say that.
Every single celestial
not
body
a-
out there rotates and
This
is
is what
spherical.
I'm
That's
just
not an
telling you
argument I would ever make.
what
Okay.
this is what Aristotle argued for the globe, that the lights in the sky are look spherical, so the Earth is also spherical.
Am
This
I
was his argument.
Aristotle?
No.
That's
Are you
not an argument
Aristotle,
I would
Fuzzy?
ever make. No, I am not.
So I'm asking you the question. Don't run from
You
it.
just did the
How
same thing to all of us.
How did they figure out?
So globe
How
denier.
did they figure out
let me
how
let me
far
explain.
away?
Let me
How did they
explain.
figure out how far away those lights in the sky are?
Let me explain it. Okay.
Go ahead.
Okay. Now I don't have the ability to bring up anything because I'm not that long here on TikTok. But so do you believe that flat or globe doesn't matter? We can know the distance between Denver and Miami.
Yes, because that's easily measurable.
Awesome. Okay. So the way the moon distance is calculated is you have two people, one in Denver, one in Miami, both looking at, let's say, a full moon with some stars around it, right? And at the same time, as close to the same time as possible, these days you can be on a cell phone and say, ready, set, go. Take a photograph of the moon that overexposes the moon so that you catch the stars in them. And with those two photos, the stars are going to be in different positions with respect to the moon. That's called parallax. I hope you understand what parallax is. If you hold your thumb out in front of your face and you close one eye at a time, your thumb will appear to move, right? And the things behind your thumb will appear to move, right? In relation to your thumb, right? And you can use those
That's
two
due
photographs.
to one of your eyeballs being the dominant eye.
No, it's actually just due to our binocular vision and closing one eye.
And one
right?
of those,
it's actually
one of those eyes being dominant, and one
no,
of them
it's
not.
It's
It
due to
absolutely
the
is.
different position of the eye. You're looking at a different angle, literally.
And
You're
one of
making a
those
triangle
eyes is
between your
dominant
two.
and one is not.
The dominance or non-dominance of your eyeball has no factor.
So to be
it's a
clear here,
triangle.
Mike, are you denying the concept of parallax?
It's a
No, what I'm
triangle
saying-
between your finger and your two eyeballs. It's
What
a
I'm
triangle.
saying is one of those. What I'm saying is one of those eyes dominantly leads the other one, right? So
First,
if you
it
stick
Fuzzy
your
was just
finger,
describing parallax.
This is-
So do you or do
you're
you
just
not
deflecting.
deny parallax?
You're deflecting.
if you guys
the
would let me
eyeball-
finish my statement before cutting me
You're
off, that'd be
deflecting.
super.
It's inconsequential to my
I'm not
argument.
deflecting. I'm saying
You
the
are
reason
deflecting.
why.
You're not letting
I'm
me
not.
state
I'm
my
saying the
argument.
reason why the object moves when you close one eye
Let me know
versus
when
the
you're
other
done.
is because one is dominant and one. Dude, I haven't been able to finish. So if you let me
Mike, you
finish,
keep
that'd be great.
interrupting.
We weren't intending to concede our time to you. We were just
Interrupting what?
asking
I
a
was
question.
trying to clarify that what he was saying was
Let him
incorrect.
finish. Let him finish.
It's due to eye dominance. That's it.
Okay, let him finish talking.
Great. You think it's due to eye dominance? Great.
I know it is.
Okay. Well, then the two cameras don't have one dominant camera or another. They both take a photograph, and they have different angles at the
It's
moon.
a single lens.
It's two cameras, one in Denver and one in Miami.
Oh my god. They don't work as a pair, bro.
No,
they work
they don't.
independently.
They both
They're
take
one,
independent
right?
photos.
Yeah, so one wouldn't be dominant. Come on, man.
So Fuzzy, how does this prove the distance to the moon or the distance to the sun?
Would you like to let me finish?
Yeah,
or
I'm
you want to
listening.
just keep
Yeah.
interrupting?
I'm listening.
Globe, I'm trying to remain calm.
We use it's okay. We use the two photos to get the angular distance, the angular difference between, let's say, one star that's visible in both photos, right? And see the difference between the angle of that to the moon, right? We can calculate that. Then once we have that, we can then drop a line that bisects the triangle between us, between Denver and Miami. We drop an imaginary line. Between those two, we get two right triangles. right? I'm not assuming it's a globe. I'm assuming it's flat, right?
I was about to say you'd have to assume it's flat because
sure, that's fine.
A triangle only works on a flat surface. Yep.
Great. We can then solve those right triangles using trigonometry, right? We know the shorter base, and we know the angle, the opposite angle, right? So if I know the opposite angle and I know the base, I can use some very simple trigonometry and calculate the other side. 240,000 miles. Every time I've seen it done that way, it's roughly 240,000 miles with some level of error.
So you used a flat Earth measurement to calculate the distance to the
I
moon.
didn't assume anything. I just knew the distance. And let's say it was a globe. That's just a small error margin in the overall calculation. If the distance between Denver and Miami is different spatially between the surface of a globe and a very straight line on a flat surface, it's only a minor error addition. It is not significant to the calculation. It adds maybe 1% to the overall calculation. It's still going to be roughly 240,000 miles.
Is that because there's a radius baked into the equation?
No, not at all.
So you got
if we wanted to get accurate, then you could use the chord that would bisect the circle.
So you got two right triangles. Just let me kind of reiterate. You're using two right triangles.
Mm-hmm.
And a triangle only works on a level surface with straight lines.
Sure, don't care. Well, so hold on. The surface doesn't matter, right? The space where you draw the triangle matters. The surface doesn't matter.
The surface does matter.
No, it doesn't.
Because it's the surface of the Earth and the shape of the Earth is what we're talking about.
I could be using the tangent between us at the point between Denver and Miami. I could be using the tangent line. That's a flat line. If you understand what a tangent line is to a sphere.
Yes, I do. And it would go through the sphere.
No, a tangent line would not go through the sphere. Then you're not understanding what a tangent line is. A tangent line does not go through a sphere.
So
a chord goes through a sphere. But not a tangent line.
So a tangent line is extended into outer space.
A tangent line, yes.
Okay. So again, you're having to bake in a radius.
No, I'm not. I told you, let's assume it's flat between Miami and Denver. We'll still get roughly 240,000 miles, even if we assume it's flat.
Because you're counting parallax.
Even if, yes, exactly. So, parallax, unless you don't believe in parallax.
So hear me out, Fuzzy Bear. You're assuming the stars are trillions of light years away or billions of light years away.
No, that is a whole different layer of measurement. Right? I was explaining the moon.
Can I say something right now?
Go ahead, Diggy.
Globe Denier, you're not letting. You're debating for me and Mike right now. You're asking a bunch of questions.
I'm asking them questions, follow-up questions to the question. Yes, correct.
Yeah,
I'm trying to understand.
Instead of letting me and Mike I'm not judging, but like at this point, it's like I could just drop and you could just debate yourself because you're doing it right now. I'm calling you out on that right now.
Go ahead,
Thank you. Thank you. That's fair.
Okay.
Fair play.
Or we could just open it up. We've been debating for a while. Maybe you want to just open it up to an open debate now. I don't know.
I'm just curious as to how they figured that out. That's all. I'm just follow-up questions.
It's simple trigonometry with triangles. I don't see how it's complicated.
Okay, so I didn't really. I'm sorry. Like I know you've been going on long. I was trying to find something. I had to walk away, and then my daughter woke up, and I didn't listen to. How did you get the parallax? Can you just summarize that for me?
Sure. You take two simultaneous photos of the moon, overexposing them to see the stars surrounding them. And what you'll get is two photos that have the same stars next to the moon, but they will be in different positions in the photos, right? Because you're viewing them from different angles. You're viewing the moon from a different angle. So the stars that you see in relation to the moon will have a different position. From their different position, you can calculate the angle between the two photos.
In order
You
for
can
this to work,
calculate
though,
the
you'd have
angle.
to prove that. Sorry, go ahead.
I finished.
Like, in order for this to work, though, you've got to prove that curve, right? Because you're forcing a straight line through the ball.
I am assuming a flat Earth. I've said that about 6 times.
You're assuming a flat
Why do we
Earth.
have
Okay,
this?
so, I got a question.
I don't understand why you would assume a flat Earth if you're arguing for the globe. I don't get that.
Because it's simple. So let me ask you. I'm going to ask you a question, and it's going to trigger you. But I just want a very simple answer. 8 inches per mile squared. Why do we use that formula?
Because it's easy to use.
Exactly. It simplifies the math.
Okay. So that did not trigger me, bro.
Great. I'm happy. Using a flat surface for this calculation simplifies the math. The difference you will get between doing the complicated math to figure out the arc difference between Denver and Miami and figure out the exact spatial distance between those two people, and the difference from that, and just assuming that, hey, the distance from Denver to Miami on Google Earth says it's this many miles, great, use that. Right? There will be very little difference in the final calculation between those two things. So to simplify the math, we can just assume it's flat.
There's a large part of science
I can't get behind
for
that.
the same reason we use a parabolic equation to simplify the math for Earth curvature instead of spherical geometry, which is possible and more accurate, but very complicated.
Okay, so on the 8 inch per mile squared, it's accurate up to 1,300 mile, pretty much like dead on.
Close. No, it's not dead on. It's not dead on. It diverges in 2 different directions. From the sphere, right? But it's good enough, and I don't argue against it. 8 inches per mile square is good enough, and it's what surveyors observe all the time. So I don't run from 8 inches per mile squared at all, right? But my point.
Can we run through an observation, Fuzzy?
My point was not to have a conversation about 8 inches per mile squared. My point is, everybody acknowledges that it is used because it simplifies the math. And I am telling you, that's why I'm assuming a flat surface for this calculation to calculate the distance to the moon, because it simplifies the math.
To be perfectly honest, and without triggering you, I can't get behind something that's like, well, we made it this way. Like, this is like, okay, we're gonna assume that it's flat, even though we know or we believe that it's a ball. And I'm going to indoctrinate your children with this based on an assumption that's not provable. That's where I can't get behind.
It's not an assumption that's not provable.
Hold on, we're going to simplify this, and that's okay.
You're
Let's
just being
spread it to the
disingenuous.
masses.
You're just being.
No, I'm not being disingenuous. I'm being literal.
Mike, hold on one second. Hold on. I'm gonna get back to topic. I'm gonna switch the topics because we beat this thing to death.
I wasn't done with the parallax though.
Digging. You want to? I'll give you a minute or so on that.
So Peter, can you feel this? I am going to have to drop and say goodnight. So I got to get up very early tomorrow morning. So Peter, I know you got this. You're more than capable. Thanks everybody. Thanks for having me up.
Thanks, Fuzzy.
Yeah, because to me, the question of the parallax thing. So I don't quite understand it, and I want to understand it because it's a topic that comes a lot in some of these debates, right? So when you say on your picture you're showing right there, Peter, can you show me where the star that you're getting your parallax would be from, just as an hypothesis?
So what Fuzzy was describing was measuring the distance to the moon, and then the stars would be like in this direction and in this direction. And basically it would be comparing what stars you see here versus what stars you see here, like from these 2 vantage points. Right. And the only the reason that there's a very small difference between the chord length and the arc length right here you can see. I've even exaggerated this
No, no,
hundreds of
no.
times.
I don't care about the chord lengths. I don't want to.
Okay.
I'm talking about the stars. Okay, is it taking in consideration the perspective of the observer? Meaning that, like, let's say you're calculating the same stars, the distance between the same stars, but they're further from one of the observer and closer to the other one, would change the angle of observation due to perspective, wouldn't it?
You're asking, like, what would it affect things if some of the stars were closer and some farther away? Is that what you're?
The big triangle, right? So you're taking the angles to two stars, okay, and then from the other side, the same angles to two stars, but one is further away from those stars and the other one is closer. So the angle to the closest person would be smaller due to, smaller. There would be perspective of those luminaries, changing the angle of elevation of those stars due to the perspective of the view. Since you're further away, the angle of view is getting smaller, and when you're closer and you're looking up, the angles are they appear closer to you. So in perspective, they will be a little bit further apart. But if you move away, they'll get closer to the center. So they move in distance with perspective when you're looking at the sky too, right? Right.
You're talking about like the stars moving in parallax or perspective between these two vantage points?
To the perspective, you're taking a shot of the camera, right? So it's taking in consideration of the perspective of the viewer, right? When you're taking a shot of the camera of the moon and you blow up the exposure to see the stars behind it, and then you take one star or two stars. You need two stars, right, for the parallax to measure the difference in angle of elevation or the close, how close they are to the moon. Is that how you measure how close they are to the moon?
No, I think maybe you're getting mixed up with like other types of measurements. This measurement is very simple. All it takes is a measurement of, like, you measure from this point and see which stars are behind the moon from here, and then from this point and which stars are behind the moon from here, and then you just measure the angular distance between those stars. So like, this is obviously not to scale, but
okay, in order to measure the angle between the stars, you need the distance to the stars to get your angle, because you need a need a reference point for the distance in between the stars to measure your angle, don't you?
No, you don't. No.
No?
No, the angle between stars is a direct observation.
The angles to the stars are direct observation. So you don't need distances between them to measure an angle?
No.
Because okay. So the angle is due to the perception of how you view it, basically, because you don't know the distance. You don't know that if you're measuring the angle between them, I can't articulate it. I don't know if you understand what I'm trying to say, Mike, and you can articulate better. It's getting late. It's like 12:14. We've been at it for like 3 hours now.
Yeah, no, I can't get behind that. You guys are using right angle geometry on a ball, and I know you're assuming a flat plane to achieve it, but why would you assume a flat plane if you're trying to advocate for a globe? I can't get behind that we don't have the mathematics and that we just want to say it's just too complicated, so we're going to simplify it.
Oh, we do have the mathematics.
You know what's simple is that we live on a flat plane, and that's why this kind of geometry works. It's basic geometry, right? This is like grade 4 shit. We don't do it on a ball.
So part of doing actual science and math is being able to recognize when things are going to have a large effect on the outcome or when they're going to have a negligible effect on the outcome. Can you see how small an effect it would have on the outcome to compare the base of these triangles versus the actual arc distance on this circle, which, by the way, is exaggerated hundreds of times from the example given?
That's not accurate. You're trying to measure to something you claim is light years away, millions and billions of light years even.
No, we were trying
to measure
tiny to the moon.
Oh, this is to the moon.
Only yeah. Did you not remember what Fuzzy was saying?
Peter,
Well, I thought you guys were talking about parallax with stars.
Peter, the other
They
thing,
use
Fuzzy.
stars for their parallax angle. That's what he's saying. They're using the stars for the parallax angle.
Correct.
But the thing is also like you're measuring it flat, but did you, in order to get your angle, if you measure it flat in order to get your angle, do you then account for curvature because your position is going to create also an angle difference, but you don't?
Nobody's measuring anything flat here in this scenario.
Okay.
We
You're
are
just assuming it's flat.
We're assuming a
Assuming
flat
it's flat.
triangle to simplify the math because we see that an arc distance would deviate by only a very, 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 very small percentage from the flat base of the triangle.
Peter, have you yourself measured the moon?
I have not myself measured the distance to the moon, but Bob the Science Guy has, and he has a video on his YouTube channel.
I also think too, Peter, because this is what I heard them do. They're presupposing that the moon's diameter is 2,160 miles across.
I was just
This
going to bring up
measurement
that.
would not require any such presupposition, no.
It does, though.
No, it doesn't.
I beg to differ, but
I want to see all the
It's
numbers.
simple geometry. You're just wrong.
That's what
Simple
they told.
geometry wouldn't assume a flat plane on a curved surface, dude. We would, you know.
It's not
Unless
my
you're
fault,
doing it
Mike,
on a
that
lake.
You can't understand the fact
Unless
that this
you're
would
doing
be
it on a
negligible
lake.
difference.
If you're gonna be a jerkwad, then I'm not gonna play on the sandbox with you. You're measuring something that's fucking hundreds of thousands or even light years away using this method. You can't do that on a ball, dude.
I'm not trying to be a jerkwad. I just think you're very wrong.
How do you prove that the sun and the moon are not the same size with this method?
Well, if you can prove that they're vastly different distances and they appear to be the same angular size, or roughly, then that
So how do you do that then, Peter?
By repeating this process with the sun as well as the moon.
Right, assuming you're a flat plane on a curved surface. Your sun is 93 million miles away. Okay, maybe it's negligible to the moon. What about the sun? That's a big difference, right? When I take a shot,
no.
This was a medal that was given for a 50 out of 50 at a mile. I've got several of them. I use them to weight the sides of my shooting hat down, right? When I take this shot, right, if I'm off by 1 little millimeter, that's a big difference downrange, dude. You're talking hundreds of thousands of miles.
Yeah, so you have to bear in mind what precision tolerances your methodology allows.
Right.
That's it.
So, I mean, if it was me, I would want to be as accurate as possible because that's how I work, bro.
Well, yeah, scientists
I wouldn't
do, and that's
assume a
why
flat
they don't
plane if I
usually-
was trying to measure on a curved surface.
Fuzzy was trying to simplify for you guys, not because he was trying to be accurate to the moon.
Is that the actual mat you guys use?
What?
Okay, can I get the big box for a second? Is that the actual math that you guys use?
Is what?
To the distance of the moon, the parallax. Is that how you do it?
There's like 100 different ways they measure the distance to the moon.
Okay.
This is just one.
Okay. I'm trying to find the one. I'm trying to find the math behind your process. That I want to see the math, the variable that you guys use, and all of it, because I'm pretty sure you guys, at one point, pre-assume something.
All right, I'm going to do
for Coriolis as well.
I'm going to do this. I'm going to wrap it up here, guys, because it's getting late, and I know a lot of us have to work and do what tomorrow. Peter, this question's for you. Why does it matter of the shape of the Earth being a globe or flat? Why is it important?
It doesn't, or it's not that important to me. I just like science.
Gotcha. End of days, you want to answer this one too, since you've been in here? Why does it matter?
Well, it's not. It matters just because it can be proven. You know, it can be measured, and It's been done. I personally can't do it, but there are people that have.
Mike, why does it matter?
Wow. This is a big question. I'm going to try to keep it small. Well, I believe this, okay? I believe when we're born into a system that essentially wants to disconnect us from what is pure, good, and wholesome in this world. And we're taught things like this ball concept, which I totally hooked onto, right? I was a big fucking lover of space and the universe and all that stuff, right? But we're living in a slave world and we work a 9 to 5 and we're not busy enough to do anything. There's a lot of smart people on this panel right now that don't have the freaking time to innovate. Our great inventors of the past, we don't have any more. Do you think we've become stupid? Because I don't think we've become stupid. I think we've become inundated with tasks. We've been smushed down to the lowest level so that we can feed the tax plantation, right? And so we don't have time to innovate. We don't have time to go look outward and discover new, greater, better things, right? And that includes this conversation. It's a tough one. And TikTok's had us be able to connect to have these talks. So it's amazing. Why is it important? Well, for me, the greatest impact that it's had on my life is that it's brought me back to creation. I've gone full circle on my beliefs, and I'm really glad that I did get brought back. I was a proud atheist, man, steering people away from creation. I don't believe in any one religion. I believe religions are a division, but I do believe that there's a creator and that there's greatness in all of us. And I find it really unfortunate. And I wish that you guys, I don't know, I don't want to straw man what you believe, but if you do believe that when your time here on this earth is done, it's just blackness, darkness, and it's forever gone, I want you to know from the bottom of my heart that's not true. And we do continue on after this. And if you don't learn the things on this planet or that you believe, or this earth that I believe, while we're here, it'll make sense in the end anyways. And it's all good as long as we love each other, right? So that's kind of what I believe. What's that? Sorry, Peter?
I'm a Christian, so you're preaching to the choir.
Yeah. Yeah. So what I'm saying is that this really disconnects us from being like really connected to each other instead of arguing about things. This flat Earth was a belief when things were wholesome, I believe, and this division is just further pushed by this. To end, I know I'm monologuing. The biggest point for me is that I have done a shit ton of research on the stuff that I was taught when I was in school, and everything other than basic 1 + 1 is 2 is upside down, man. And I don't want my kids learning lies. I do teach my kids both models. They do know both models, and they know the truth. I don't want my kids learning lies anymore. And I don't want any children learning lies. I want us to learn the truth, and I want us to ascend into a better frame of mind. We shouldn't be fighting. We should be loving. And with that, I'm going to mute. Love you guys.
Digging, what's your final?
Why does it matter, or does it matter?
Yep. Why does it matter? Why does the shape of the earth matter?
In the whole big picture, it doesn't really matter. But in the end, on a spiritual level, the flat earth to me brought me a lot of good in my life, right? Because it brought me to a creator. Like I could just copy paste what Mike said. I don't know if it's because we're Canadian, but when you ask that question, whatever Mike said, all that Mike said was basically what I was saying, right? I was planning to say. So now I have like nothing left to say because, yeah, my life changed when I went and tried to debunk flat earth. Like I was an atheist, sinner, you name it, man. Just changed my life for the better. Everything since I started to be positive and try. I want to fight the divide. My goal is to fight the divide, and the creator brings love. And with the globe model, you don't have a creator. You have the Big Bang. You have the evolution. You have nothing. You came from nothing basically with the globe model. So a creator gives me a greater purpose, and it changed my life because I love everyone. I try to respect everyone as much as I can. When I feel attacked, I will attack back. But it's just the whole unity of it. I've met a lot of good people. To me, it's my belief, and yeah, I don't know, man. Mike was too good. I can't compete with that. I feel like I sucked tonight. I'm sorry I failed or whatever, but like,
No, bro, you've been good. Don't worry about it, bro.
it's been a
You're
good.
tired, man. We all had a long day of work. We all had a long day of work. Our
Yeah.
brains are fried. It's late. You know, that's just how it is sometimes. Peter, thank you for coming on. Go ahead, guys. There's a poll. There's a poll right there. If you could please vote at the top above the host, please click that poll. Give us a vote. There's 86 people in this chat. Only 23 have voted. If you could give us a vote, please.
Could I ask a question as a Christian, to Peter? Where does it say in the Bible that the earth spins?
It doesn't.
And where are the waters above the firmament?
I don't know for sure, but I always assumed they were clouds when I was a kid. The other possibility is it could be something related to the cosmic microwave background.
And what's the windows of heaven that opened up to flood the world?
That's just a turn of phrase referring to rain.
And where are the fountains of the great deep? Where did the water recede to?
Back into the great deep.
Into the great deep.
I don't understand the question.
So now there's water under the earth, right? A shitload of water?
Yeah.
Really? You believe that?
Well, it might not be in liquid form. I think they recently discovered like massive oceans worth of water bound into the molecular structure of rock just because the pressure is so deep or great down there. But we don't know for sure. I mean, what we have is the text of Genesis, and we have photos of the globe.
Yeah,
Globe, can I say something?
Hang on. Did
is
God
angels
stop
here?
the sun? Did God stop the sun, or did he stop the earth
We're
from spinning?
basically done the regular debate. We all,
but why is he here?
because
Did
we called it a night. We called it a night. So this
I want
is
to ask
open
him as a
now.
question from a
I'm just
Christian.
asking.
Christian
I'm
to a
just
Christian.
asking.
This question from a Christian. Did God stop the sun from moving or the earth from spinning?
Depends on your perspective.
Did the Bible say that he stopped the sun or the earth?
The Bible says he stopped the sun. That's a terrestrial perspective.
Yep. And when he made the sun go backwards in Isaiah, did he stop the earth from spinning and he made it go backwards? Did it say that?
Again, it depends on your perspective. The text is written from a terrestrial point of view.
So great earthquakes and waters went everywhere, yeah, when he stopped the earth and spun it the other way?
No, it was a miracle.
Oh, it was a miracle.
Why are we
What about-
debating fiction?
Let me ask real quick, Peter. When Jesus was taken high enough to see all nations, did he see around a ball?
No, it could have been a vision, or it could have been referring to like all major nations in the known world at the time. There are a number of ways to explain that passage.
Yeah, but if it was a vision, he wouldn't have to go to the top of a mountain to have a vision.
He might have been at the top of the mountain in the vision.
And when Jesus ascended up into heaven, which way is up on the globe?
Away from the center.
Oh, so he ascended down. Like if he was in Australia, is that the opposite direction to up in the north?
There are places opposite to other places, yes, but
Yeah,
Jesus
so
was
like-
in Palestine, so his direction of ascension was away from the
Angels,
center
you just
at
love to
Palestine.
pivot. You
All right,
pivot on a ballerina.
Let's hear from let's hear from everyone else on the panel. We just had quite a debate. End of days. Go ahead, share your thoughts, bro.
No, I just don't understand the point of angels being here and asking a multitude of questions that they're just coming from out of left field everywhere.
I know why. End of days. So, as a Christian, it's our job. As a Christian, there's a verse called Ephesians 5:11. Okay, and angels probably know what that is. Peter, you probably know what that is, right? It's I shall have no fruitful deeds of darkness, or put myself away from the fruitful deeds of darkness. Okay, and so anyway, yeah. So what he's saying is there's many aspects of the Bible that point out that the Earth is flat and stationary, and it's actually well. Hold on.
I asked you where does it say does the earth spin? And
hold on. So you have to. So basically, Peter, what he's saying is you have to jump through mental gymnastics to create a spinning ball from the Bible verses. And in my experience, it's easier to bring an atheist to Jesus through flat earth than it is to bring a Christian to flat earth. That's someone who's
That's an
already
argument from pragmatism.
No, I'm just telling you, if someone I've had better luck. I've had better luck at explaining. I've had better luck of showing people that the Bible's true by proving flat earth and leading them to Christ than showing a Christian that denies the Bible and what the
That's
Bible
an argument
says.
from pragmatism. That's not a good hermeneutic at all.
Right. So the waters above and below the firmament. Where's that again on a globe?
The waters above the firmament, as I said, I always thought they might be clouds. Another possibility is the cosmic microwave background. We don't know for sure.
But the clouds are not the firmament, dude.
The firmament is the sky.
He placed the sun, the moon, the stars in the sky, bro. So it has to be above the clouds. And the sun and the moon and the stars have to be contained, and it says the sun is a light and the moon is a light.
So the word firmament is mistranslated. The actual Hebrew is rahia, and it means both the atmosphere and all of space.
It means a solid
together.
expanse. It means a solid expanse.
No, it does not mean that.
Yes, it does.
It does not mean that.
Yes, it does.
Guys, let's hear from digging real quick.
No, bro. It does not mean atmosphere or space.
I just want to say a couple things because I'm gonna go to bed. First of all, it was an honor to be here, Globe Denier. I know it didn't work out with your live, but it was it was good up to a certain point where everyone was starting to get tired and triggered and stuff like that. Also, Mike, you're amazing. I love you, bro. It was nice to be with you. I'm happy. It was a good choice, the Canadian team.
Yeah, man.
It was fun.
Cool.
It was nice to debate with you, Peter. You're very knowledgeable and you're very polite and respectful. So it was a good feel to have you here. Other than Deddy got triggered and we kind of lost it at one point with Deddy. He brings good point, but he lost it and we lost a bunch of time over some stuff. But thank you, Peter, for being calm and respectful and just letting us speak. And I loved it. So I'm going to go to bed. Thank you, End of Days.
Can I bring something up?
Yeah, what's up, buddy?
A lot of flat earthers like to say that, the globe model is they're trying to hide God. And, God is doing a pretty damn good job of hiding himself, whether it's a globe or whether it's flat. I mean, he's not going to appear out of nowhere just because hypothetically, if the world were flat, he's not just going to, here I am. No, he's doing a very good job of hiding himself.
Yeah, but if you can show that, if you can show God through His creation, then it reveals God as a creator.
Let me ask you this: you think God is going to what shape do you think God is going to create out of all the shapes? You think he's not? You think he's going to create a flat plane versus a sphere when the most important object in nature is a sphere?
Yeah, that's what it says in the Bible. But unless you can show me,
you can't. Yeah, but the Bible is fiction.
No, the Bible.
I used to be a Christian. I used to be a very devoted Christian.
Show me in the Bible where it says that the Earth is a spinning globe.
Peter, will you explain to them you can't use the Bible to support flat Earth theory?
You can actually.
It's a flat Earth geocentric.
I've been trying.
Because End of Days. So for thousands of End of Days, you should go watch this documentary called Heliosorcery, and it explains that for hundreds, if not thousands of years, the church was the authority on everything, and everybody knew the Earth was a level topographical plane. And it's when scientists started infiltrating the church and coming up with all these theories. Then they changed it to it's
based on a historical myth.
That's
Peter,
actually true.
So Peter, are we the center of the universe, like it says in the Bible?
The Bible doesn't say that.
Oh, so it says that the sun is the center of the universe, of our solar system?
I'm sorry, what did you say?
So the Bible says that the sun is the center of our solar system, huh?
No, it doesn't say that either.
Oh, well, it doesn't say that we're sun worshippers, right?
No. The
So
Bible
after-
is not an astronomy textbook. I don't know why you expect it to
What
have
is
an opinion on the
biblical
shape of the
cosmology?
Earth.
Biblical cosmology.
Angel,
Hey,
Question.
Peter, Peter, I need to ask you,
Yeah.
what gave you the authority to tell people how the Bible was to be interpreted?
Well, if you want to talk about hermeneutics, we can talk about hermeneutics because
Well, I want you
it's
to
not
show
that
all
I have
about
authority.
No, I want you to show me heliocentrism in the Bible, seeing as it's in the Bible that you believe.
That's a false challenge. I mean, that's
you
a
can't show it.
completely arbitrary challenge.
But I can show you geocentric verses.
I bet you can't.
The earth takes shape like clay under a seal, Job 38:14. Also, it says...
That's phenomenological.
Also,
it's,
it says...
it's just describing from a terrestrial point of view.
It says the shape of the earth takes shape
just-
like clay under a seal. Do I need to show you what a wax seal looks like? Because it's flat with upturned
Upturned edge.
Also, what's important too is it says test all things and hold fast to that which is true. And judging from the 3 hours I've been here, you certainly have not tested your globe religion and proven it to be true.
Well, I'm glad that you're not the judge.
May I ask a question?
Peter, I just want to know, right? Did you say that the horizon at sea level, you can't see the curve of left to right, yeah?
That's correct. If you're expecting curve left to right and you're at sea level, that's not something you would
Okay,
see.
so what creates the horizon?
That's just the threshold where the rays of your vision are pointing down versus up.
Wait, so is the horizon created by eyesight or by earth curve?
I don't like these, I don't want you to, I don't like how you're trying to lead me around like a dog on a leash. If you have a point to make it. You shouldn't need my help.
It's a very simple question. Does the horizon get created by...
That's how you strong arm the conversation, is by pretending they're simple questions, but there's like a certain series of them that you have to.
Angel, it's all right. He doesn't want to answer you. He feels like a dog being led around on a leash. Johnson, do you have anything to say with Peter before it seems like he's still on?
Yes, I just have a few questions for Peter. According to the known or even perceived biblical writers, is there any information that indicates that any of the writers, prophets, or anybody associated with the writing of the Bible, that they believe that we are on a spinning ball spinning in space? Any indication at all?
That was not a primary focus of any literature on the subject, but there are indications that the civilization around them, at least in the New Testament, did have that knowledge. So,
Which civilization are we talking about?
I've got a good question, right? You know when they built the Tower of Babel to reach onto the heavens? Why did God stop them from reaching onto the heavens if heavens is just a empty vacuum?
Well, I can tell you it's not because he was scared they would get in.
So why did he stop them?
It's because he was recognizing the danger of human hubris.
Do you see the amount of mental gymnastics you have to do, dude?
No, but the text
It's not mental gymnastics.
No, but hold on, guys. The text does say that God said they would be successful if they were to continue. The text says that.
It says they would have reached unto the heavens.
Exactly. It
So
says
is
that.
the heavens, if the heavens is a vacuum according to you, then how does that make sense, dude?
The heavens are not a vacuum, according to me. That's a straw man.
Well, so what is it then? What's above the gradient? What is it?
Well, the heavens includes the atmosphere, so that's why I was trying to.
So they reached unto the.
Includes the atmosphere.
They reached unto what? They were trying to reach unto what?
That was their description of what they were trying to do. It may or may not have even described accurate cosmology. I mean, if we look up the verse,
So the Bible's not accurate now?
That's not what I said.
So what do you mean by they
Your
didn't?
questions are
describe
so
accurate?
disingenuous. I really don't like your tone, Angels. I really don't
I don't
like
like you either.
It's all right, Peter. You haven't
Yeah,
really
I can
liked
tell.
the entire debate. You've been crying the entire debate. So, Johnson, do you have any questions for him before he runs?
Yes, I was trying to finish my question. You said that the civilization around the people who wrote the Bible believed in the current accepted model. I'm not asking about the civilization around the people who wrote the Bible. What did the people who wrote the Bible believe as it relates to the
Yeah, we don't know. No, I don't know, and you don't know. We don't know.
No.
Is there any indication that the Hebrews believed in a particular vision, a particular version of what the earth looked like?
There's no indication one way or another about exactly what they thought it would look like from, space or whatever.
No, we're not assuming space. We're not assuming space because nobody assumed space at the time. I think you're being disingenuous. Let me tell you why. The information regarding the outlook of the Hebrews as it relates to the shape of the earth is the evidence is copious, and everybody knows it. Nobody associated with the writing of the scriptures in any way, shape, or form had any idea other than a level plane with literally a dome. I'm not saying you should believe what they believe. I'm just saying that's what they believed.
Well, number one, you are quite overstating that evidence, and number two, the model, the biblical cosmology that you keep referring to, that was not robothemist.
That was not what?
If there were people who believed the Earth was flat during that time, they almost certainly believed the sun traveled underneath the Earth at night, which is not compatible with your view.
That's not true, Peter. Let me explain. Peter, hold on, guys. So, Peter, on the big screen here, this is biblical cosmology. All right. If you Google biblical cosmology, this is what you're going to come up with. Where the sun,
because it comes from Michael Heiser, and all the flat earthers have taken it and gobbled it up and reposted it.
It's a Hebrew depiction.
That's out of a Hebrew Bible, Peter.
It's right out of a Bible. It's right out of a Bible.
Then question, Peter.
That picture is not right out of the Bible.
Yes, it is actually.
Yes,
so, Peter,
it is.
let me explain it.
Yeah, it is, dude.
Peter,
Yes,
let me
is,
explain
Peter.
the history to you, Peter. They actually used to print this in every single Bible up till 1958, and then they removed
the modern version.
Right.
Since
and
1611?
Yes, actually, there were many.
Did you know there were Bibles before that?
Yes, and even in the Geneva Bible.
What do you think they had?
The Bible does not come with pictures. I hate to break it to you.
Joking? Yes, I'll pull up another one, dude. I'll pull up another one.
Did you just say
the inspired word of God does not include illustrations?
Hey, Peter, I got a question.
Joking,
I have a question for you, Peter. I have a question. When Jesus comes on the second
I haven't
coming,
asked anything yet. Hang on.
on the second
So, Peter,
coming,
who invented the Big Bang Theory?
All right, Johnson next.
I'm not familiar with who invented the Big Bang Theory. I've heard it was a
It was
Catholic
a Jesuit priest, a Jesuit Catholic priest that invented the Big Bang Theory.
Okay.
Space was not part of the Bible ever.
I didn't say it was. I also don't subscribe to Big Bang Theory, so I don't know what.
All right.
You believe
let
in
me ask a question. Let me ask a question. Peter, question.
Do you believe in?
So,
Sorry, go ahead,
do you
Johnson.
believe in the second coming of Christ?
Yes.
Does the Bible teach the second coming of Christ?
Yes.
Right. It says that he will come through the clouds and all eyes shall see him. Question. Where on the earth will he come down where all eyes will see him?
Can you give me a chapter and verse?
I'm asking a question. It's a very simple question. We're on a ball, right? You believe we're
quoted
on a
scripture.
ball.
Can you give a chapter and verse for the scripture you quoted?
I think we all agree that it does say that he's going to come from the sky and all
I think
eyes.
it's in Revelation, Johnson. Yeah.
Yeah, I think it's in Revelation. You're trying to be very disingenuous, my brother. Very disingenuous. But I'll continue. All eyes.
Did you just
shall...
say that I was being disingenuous?
No, you know what I'm talking about, but you're trying to use semantics.
No, I'm trying to perform accurate exegesis.
No, you're being
which is what you're asking me.
Let's perform accurate exegesis. Can someone pull it up for me, please? Since you want to perform accurate exegesis, can someone pull it up? I don't have access to a computer. I can find it right now. Please, since Peter decides that what we all know to be true, we have to show him what he knows and what we know to be true. Can someone please help me out? This is getting ridiculous.
Yeah, Peter, what I'm trying to get at is you got
hold on, my brother. I really want to get at this. Please, I'm asking you, please. Can you
look it up? I don't know. So you want to just pause the live for 30 seconds while we go get your evidence, bro? Come on, let's move with it.
All right, let me move with it. Let me move with it then. the Bible does say, and of course he's going to want me to quote the chapter and verse, but everybody knows the Bible does say that Christ will come through the clouds in the same way he went up through it. Yeah, he's going to come back just like that, and all eyes shall see him descend. No, on a ball, that is impossible. All eyes cannot see the heavens, the kingdom of God coming
Revelation
down
1:7.
through the sky.
Revelation
what?
1:7. 1:7.
Thank you very much.
1:7.
Thank you very much. So the point is, only on a level plane can everyone see something coming from the sky down to the earth. No one, if it's coming down in America, Australians won't see it. If it's coming down in Europe, China won't see it. That's the point I'm trying to make.
It's on screen.
That the verse does not establish that.
Says
What does
every
the
eye
verse
will
say?
see him. It's on screen, bud.
Yeah, I see it now.
It says it.
It does
I just
not
looked it
establish
up.
that.
Look, he is
It
coming
does-
with the clouds, and every eye will see him, even those who pierced him.
Yeah, what does it
Yeah,
establish?
that
All the
does-
people of the earth.
That doesn't establish anything about Earth's cosmology. That could
Jeez.
be over a period of time, all eyes will see him, or it could be after all people are
Mental
gathered to one location,
gymnastics is
or it could be after they're
unbelievable.
taken off the earth.
Goodness.
We don't
This is
know. It's a
unbelievable.
revelation.
Are you guys recording this?
Go to hose real
No.
quick.
So
You guys
yeah,
should record this for
So
posterity.
Peter, what? So here's what we're getting at here, Peter. You've got all 7 of us here are Christians, okay, and 6 of us know
Negative.
the
I am not a Christian.
Mike. Sorry, but Mike Flat Earth did lead you to a creator, right?
Yeah, I definitely believe in a creator. I just don't subscribe to any one religion.
Okay, so you got 6 of us here, Peter, that are Christians.
I'm not a
5 of us-
Christian.
Hose, you're not either.
No, I'm a believer, yes, but I am not a Christian.
Oh, I thought
Oh,
you believe in a
and-
creator.
Yes.
Okay,
Right.
he believes in a creator.
And hold
my
on.
bad.
Let me say,
So,
I'm Catholic.
Peter, if you want to laugh like a condescending
we
prick,
all-
that's
so we all
cool, but
believe-
I'd love
we
to
all
have a
believe in
conversation with you
creator.
about why I
So,
believe
I want
that.
to
so
make it
let me.
clear.
I'm sorry. Let me rephrase. We all
Also some
believe in a
believers.
creator,
Yes.
right? We all believe in a creator, and 6 out of 7 of us know the Earth is flat. Okay, we're trying to help you understand our perspective and our point of view through a biblical lens. Okay.
I'm pretty sure I do understand your perspective. I reject
Okay.
it.
So, well, if you reject God's creation, you're rejecting His word.
I did not reject God's creation or His word. That's your
Okay, then what-
interpretation because you conflate the two.
What
Alright,
You
Peter,
conflate your
firmament
beliefs
as,
with
Peter?
God's.
Where
Yes,
does
sir.
it
On
say
what
What a firmament
authority?
is.
On what authority do you accept the globe as being true? On what authority?
Yeah, like, you know, the same people that bought you the globe, Jesuit priest models, the same people that bought you evolution, right? Do you believe in evolution too?
No, I don't believe in evolution, and it's not the same people that.
Hang on, I want
Nobody-
to hear his explanation on what the firmament is, since he's not rejecting God's handiwork.
I already said it's the clouds.
That's not the clouds, bro.
That's not what I said. That is not what I
let him
said.
talk then. Go ahead,
What's the
Peter.
firmament?
The firmament is a mistranslation. It's actually a Hebrew word rachia, and it's best translated expanse. All it means is basically the sky, including both the atmosphere and space above it.
No,
I don't know if you realize, but rakia means solid beaten out. Like, are you aware
That's
of that?
not what it means.
Yes,
That
it
is
sure
not
does.
what it means.
Yes, it does.
Nope.
Yes, it does.
That's just not wrong. That's just not
Okay.
correct.
Nathan,
So
can you
hold
bring it
on.
up?
We've all been trying to have Peter look at it a different perspective. I'm asking Peter a question now. On what authority does he believe that we are wet balls spinning in space?
On the authority that God gave Adam to name the animals and study his creation.
So where in the Bible does it say that?
Say what exactly?
What you just said. You said the authority that you're getting, the authority on which you believe that there's a spinning wet ball is on the authority of God giving Adam.
God gave all of mankind a mandate to fill the earth and subdue it. And as the first step in that,
I'm not disputing that. I'm asking you, what authority are you using in your belief that we are on a spinning wet ball in space? On whose authority?
Let me just help him out. He's asking like what belief is it? Scientific or biblical?
it's
No.
scientific.
on whose authority? What science is a process, okay? Science is not a
Yeah,
person
I
or
have
a thing out there.
personally measured sunset and verified that the sun declines at a linear rate instead of an arctangent rate, which by the laws of geometry dictates it does not move away from us according to a robothamist model.
Okay,
But
That
that
means that
assumes that the sun is a
3D
physical thing in the
Euclidean
sky,
model.
doesn't
What are
it?
you talking about, Peter?
No, but hold on. What you said a while ago regarding your measurement, let's use your measurement. Do you assume the sun to be a physical thing in space, 93 million miles away in your test?
no, not at all.
What do you assume the sun to be, and how far do you assume it? Do
I
you
make
assume the
no
sun is a-
assumptions about the nature
Then
or
how do
distance
you
or
measure
size of the sun.
something? Then what is the sun then, and how far away is it?
What that you're changing topics.
No,
You asked
I'm
me
asking
how
a
I know
question.
the
I'm
Earth is a
asking a simple
globe.
question. What is the sun, and how far away from the ball Earth is it?
I mean, I didn't personally measure that. I
Okay,
believe
therefore,
that science is.
Therefore, you, as you said, you believe scientists did that. Okay, I'm saying you have to know these distances in order to come to a conclusion regarding your test. You cannot say that the
That's
sun.
not correct. No, that's not correct at all.
So you're telling me that the distance of the sun away from the Earth and what the sun is irrelevant as it relates to your test?
Yes, absolutely.
Wow.
Okay, so so when
I
straight
can
lines,
show you if you want. I have the
look,
geometry diagram on my
real
computer
quick,
right now.
just real quick.
All
When
I'm
straight
saying
lines,
is your test is assuming that the sun is 93 million
No,
miles
it's
away.
not. I just told you like 5 times it's not. You
real
just
But
don't
how
believe
is
me
it?
because you don't understand my methodology.
Peter,
I can show you.
Okay, Peter, real quick, man. When when straight lines converge into the horizon on a flat road, is that because of Earth's curvature?
No.
Okay, so if the sun was more local and it moved far away, would it recede into the horizon eventually?
Eventually, but it would follow an arctangent function. It does not.
What do you mean by arctangent function?
So in your picture behind you, you notice how the spaces between the streetlights are larger when they're closer and smaller when they're farther away?
Yeah, are you aware that even in the globe model, are you talking about the size of the streetlights, like the physical size?
No, I'm talking about the space between them.
What about it?
It's following an arctangent function. It's geometry.
Right, but
Let me show you.
The sun moves at a constant rate, right? Because of the spin, right? So what does the distance between them matter?
Hold on a second.
But you did just admit that the sun would recede into the horizon if it was more local and moved away. I like that.
Yeah, of course. So here are 2 geometry diagrams I made demonstrating this concept, okay? When we observe the sun's altitude above the horizon, above eye level, which if there's something blocking the horizon, we can establish that with a plumb line and a level if we want, whatever. The altitude we measure above the horizon, that gives us, what that gives us is an exact ratio of the height to the distance.
Okay, why are
we
you
take
using
that altitude?
Why are you using a right angle triangle, right? Why are you using right angle triangle?
Why are you using a straight line on the ground?
Because I'm showing what it should look like on a flat Earth.
Okay, now does it look?
Tell us what it should look like on a globe.
How does it work on a globe then?
Because I thought you were
On
going
a
to show
globe,
us an arctangent function, and that was the proof it's a globe, bro. Now you're showing us an arctangent function and saying that, oh, this is how it works on a flat Earth.
I'm saying that the arctangent function is how it should work on a flat Earth, and it does not follow that arctangent function. It follows a linear function, like I think Angel said that.
Yeah, I thought you were showing me proof of the globe, how it works on the sphere.
Globe now.
I was trying to demonstrate the concept of what I was describing.
Yeah, go ahead. We want to see the globe eventually. Go ahead.
You were showing the globe.
Let him finish. I really want to see it.
Okay, so this measurement of the altitude above the horizon. It tells you a ratio of height to distance according to an exact formula.
If there was
Tangent
no
of
atmosphere,
altitude.
For a
agree.
flat
Yes.
Earth, bro. So you're saying it works perfectly on a flat Earth, and you've got formulas for it? Well, welcome to flat Earth.
Can I please finish my
No,
argument?
let him finish. I want to hear what he has to say. Please. Go ahead.
That exact formula is if you take the angle, take the tangent of the angle. That's not a tangent, meaning the function, not the line. Okay, the function, the tangent of the angle. It gives you the exact ratio height to distance. Now, if all you know is that angle and that ratio, you don't know for sure how high it is or how far away it is, but you know the ratio, which constrains it. Okay, so if it's, let's say in this red scenario, it's 36 feet away from you, that would mean it's 100 feet above the ground. Or if it's 2,000 feet away from you, that means it's a mile above the ground. Or if it's 36 million miles away from you, that means it's 1 million miles above the ground. You see how it's an exact ratio. You
How's
don't know
it-
the numbers, but the numbers are constrained.
Right.
Okay,
So, Peter, what you're showing us
How
is
do
a
you-
flat Earth model. Let's see the globe now.
Let's see the globe, yeah.
Yeah.
I wasn't finished. So here is, if the sun is moving away from you at a constant height, you still know the exact ratio from the angle. So all you have to do is basic algebra, solve for the angle to predict it. If the distance is increasing while the height is staying the same, it should follow this arctangent function. That's
So-
why in the background of Angel's picture, the street lamps, the distance between them was getting smaller as they were getting farther away. It's not because the street lamps themselves were closer together. It's because of how perspective works based on basic geometry.
Fine. Now show us how it works on a globe model using that you have right there. Show us how it works on a globe now.
But the picture I have with the sunset.
Hold on, let him show us. We really want to see this. We want to see how that works on a globe.
So
using
just
the
to hammer this home, here's me demonstrating a similar thing to the street lamps. I was just holding a flashlight, and I've superimposed pictures at a constant interval. We see the same thing, right? Distance between images gets smaller as it gets closer to the vanishing point.
We get that. We want to see the same diagram that shows how it will work on a globe
Here
now.
was my measurement of sunset. The distance between these images of the sun never changed throughout the 3 hours of this time lapse. I have two versions superimposed next to each other to show this is regular without a filter. This is the same time lapse, but with a filter because I had two cameras next to each other. Now it's still a little overexposed here. Don't get distracted by that. The fact is,
Peter, well, look at the bottom of your screen, bro. The sun is vanishing into a dot.
Yeah. What are you on about, dude?
And
Hold on, guys. Peter, I would love to see you use that same simple diagram that you used before. Hold on, guys. Guys, just give me a sec. Peter, I would love to see you use that very simple those two simple diagrams you gave before to prove how it would work on a globe. Remember, the bottom of your triangle now is not flat; it's curving. So I want to see that similar diagram, diagram that shows how it would work on a globe.
you can't perform that. You can't perform that trigonometry on a globe.
Hang on, you literally just proved that the sun appears to move away and shrink and vanish behind the horizon.
Well, you guys can think so. The debate was over a few hours ago, or like a little bit ago. So
what's the size difference between the start point of that sun and the finish point of that sun? There's a obvious angular size difference.
Yeah, why is that?
And it's curving. On your religion, you're just moving, one direction. The sun would just move one direction. It wouldn't curve around you.
Nathan, I don't approve of you calling it a religion.
So what's wrong with that?
Whatever you want.
It's brightness. What you're seeing is a change in brightness, and not angular size of the sun. Like I said, I didn't control for perfect exposure on the sun during the time lapse.
Peter, the two first diagram you gave us was very simple, right? It's a diagram. Can you provide a diagram like that that proves that the sun is going, not just vanishing into the horizon, but is going over a curve?
By the way,
Diagram.
bring up the green flash, and it's over.
Hey guys,
I
I'm
made
gonna
that
I'm gonna
diagram to demonstrate a specific concept. I did not. You can't apply that same concept to the globe at all. I don't just have whatever evidence you happen to ask for at any given
But you
time.
just use two very simple diagram with a stick man and triangles, with the bottom of the triangle being obviously flat, to show, as according to you, that the sun could not be moving into the horizon. I'm saying, using the same diagram, you must be able to tell us or show us how it works on a globe with the bottom part being curved. That's not hard.
I don't know why you're saying that.
Why would
You
you
don't
just
know
have
why?
math and formulas for a flat Earth and not your globe religion, bud?
Exactly. How can't you show us
I didn't
the
come
same
here for
diagram?
this.
Peter, I'm sorry, man.
Is it-
Look, I'm gonna show you one more thing. Because I know you're a Christian, and I know you, and you're trying to do. We're trying to do what we think is best to show you what truth looks like. Now, I don't know if you can see this, but this is 2 Timothy chapter 4. If you want to pull it up on your screen, you might be able to find it. Okay?
I can read it.
Can you read that? Can you read that to us?
Which color do you want me to read?
Just where it starts, the highlight there.
For there is going to come a time when people won't listen to the truth, but will go around looking for teachers who will tell them just what they want to hear. They won't listen to what the Bible says, but will blithely follow their own misguided ideas.
That's what I wanted to share with you. That's what's happening right now in this world. People are not following the truth of the Bible. They're following misguided science, and they're searching for misguided ideas.
So, Peter, you said
very naive.
You say you don't believe
Listen,
me.
I think I can help.
Hold on, real quick, Johnson. I've been quiet for a little bit. I've got the Vatican.va here. I've got friggin' where's this BibleGateway.com. I've got this comparative site that shows all these different Bibles and how they talk about. Look at this solid arch, right? We've got firmament, firmamento. You know, we could go on and on. The Vatican talks about it being a dome. Like, man, it's like it's in front of your face, bro. You know, and that's why
Those are not correct
and
translations.
These are all
I have
all
the
of
Hebrew
these
right here.
are comparisons. All of them are comparisons. So God made a dome and it separated the water under it from the water above it.
All different versions.
That's the Good News translation with Apocrypha. So there's like lots of different. Dude, man, just go
You're
look.
cherry picking,
It's
and
right
those
there.
are not correct
Here's the
translations.
Hebrew.
I'm not cherry picking. These are tons of examples.
Let me read the Hebrew. It
Read the
says,
Hebrew.
the first one says an expanse, but there's a second definition, a firmament, a vault of heaven supporting the waters above. You read the word vault, it says it's a roof in the form of an arch. So the sun and the moon and the stars are in a roof in the form of an arch. That's what your Bible says, Peter.
Johnson,
That's
I think
true.
I can help answer the question you were looking to answer. On a globe model, when the sun goes across the sky, it goes across at a very consistent 15 degrees per hour. It doesn't follow an arctangent pattern of when it's far away, it moves a different angular size, and when it gets right above you, it kind of zooms past you, and then when it goes far away on the other side, it moves at a slower angular size. That's not what we observe in reality. In objective reality, the time-lapse sequence that Peter showed demonstrates that the sun moves at a consistent rate across our sky, not predicted by a floating ball above a flat plane. That is not predicted by it.
All right.
That's how it moves on a globe.
It also
That's
has
how
an
it
arc
moves
to it.
in reality.
Guys, there's something I think
In
we flat
reality,
earthers are
it
missing.
moves at 15 degrees per hour. You can go out and measure
I
it.
get
You can
you.
do that yourself.
I get
Peter
you.
did.
Yeah, I get you, Fuzzy. But I think there is something that we flat earthers are missing, and it's a big thing. everybody's assuming that the sun is a physical object in space, in the sky.
Still moves. It still moves.
I'm not saying it doesn't move. I'm saying we are all making the assumption that is a physical object in space.
Wait, he just said the sun moves.
You guys,
I gotta go.
Peter,
good night.
one moment, if I could.
Okay.
Finish this verse for me. From the rising of the sun to the
setting.
Yes, setting. Not faring, setting.
Okay.
Well, have a good night.
Okay, go with the root word of setting.
Thanks for proving that the
Going
sun moves,
down.
Fuzzy
The
Bear,
root
and not
word
the earth.
of setting is
Yeah,
going
you just
down.
said the sun moves, Fuzzy.
You just said you just proved the sun moves, not the earth spinning. Thank you for that.
Motion is relative. The sun moves across our sky because we're rotating past.
Setting is perspective.
So
Setting
the
is
stars,
perspective.
Fuzzy. The stars move, right, in the sky?
The stars move, yes.
I thought the earth
They do. Polaris moves.
I thought the earth spins.
Polaris moves.
All right.
Provably.
So Fuzzy, question.
Here we go, guys. Let's all
What's the
say bye
nearest?
here real quick.
Guys, may I ask a question? What's the nearest
Have a good night,
star
guys.
that we can see in the sky?
Thanks.
How far
Hey,
away
Peter,
is it?
thanks for coming on, man. I know you're tired. I am too.
Thanks.
Cheers,
Have a
Peter.
good
It was a
night.
good debate.
Yeah. By the way, Fuzzy, are the
Good
clouds
debate,
stationary as well?
yeah.
Are the clouds stationary as well?
Oh, absolutely. Every cloud is just pinned right to the ground. Absolutely. You ask the most ridiculous